check 2. You guys should be able to hear me. Yes, good. And now you should be able to see my screen. Perfect. Then I am ready to go whenever you guys tell me to. Sounds good. Okay, it's 9:30. I'm just waiting for confirmation to start. No worries. Thanks. And it looks like I am live. So I'm going to go right ahead then. Hello, everybody. I am Jeffrey Hauser. This is an introduction to Angular presentation. So really designed for people who don't know anything about Angular and want to learn. So first, before I jump into it, who am I? What gives me the right to be up here teaching and preaching to you? So I write a small book series on Angular, integrating with different backend technologies. You can find more about that at learnwith.com. I've also, for the longest time, I was a small business owner who did custom software development. I did that. That was my primary income for a very long time. I gave that up a couple of years ago to become a lead software engineer at Disney Streaming, and I work on backend tools for Disney Plus. So that's who I am. I've been doing this sort of stuff for a very long time, and I've worked with everything from super small projects for small businesses to big, large government projects and everything in between. So what we're going to focus on today, we're going to talk about what is Angular and why we would use it. I'm going to go into Angular components and a deep dive into what they are and how we use those to build Angular applications. And then I'm going to talk about Angular services and how we can use those to share data between different Angular components. So first section, I'm going to go over a brief history of Angular, what it is, why we use it, and then I'm going to show you how to create and run an Angular application. So Angular is a web application framework designed for building single page applications. It really is designed to decouple sort of DOM manipulation from application logic. So we have separate HTML templates and separate TypeScript or JavaScript code that we use. Angular knows how to work them together at runtime to build our screens that we show to the users. And single page applications are basically the latest form of application development on the web. So a brief history. AngularJS was released back in 2009 as the beta. This was a precursor framework to the Angular that we know today. It took a few years, but in 2012, AngularJS 1.0 was released. So that's notable. In 2016, AngularJS added sort of components into their architecture, which is really a push towards Angular that we know today. Angular is different than AngularJS, although they're similarly named. They come from the same team, but Angular was a brand new TypeScript-based framework and very component-heavy architecture for building single-page applications. Angular CLI, which is part of the Angular system, is basically a bunch of scaffolding and code generation tools. Came out in 2017. In 2018, the Angular and the CLI versions started to sync. In 2021, Angular 12 came out, and also AngularJS, sort of the precursor framework, is reaching end of life. But so that's sort of a brief history of where we're at. There's about 2 releases of Angular a year now, following the Chrome sort of release versioning scheme. So what is the Angular ecosystem to build these single page applications? So there's the Angular framework, which is a TypeScript framework built on dependency injection, built on components. It's designed from scratch to be testable, so we can easily build testable code. We have the Angular CLI, which is our build scripts, our scaffolding. It has code generation, easily generate components or services, or providers, or whatever we need to generate to build our Angular applications. And also coming from the Google team, there is Angular Material, which is a UI library based on Material. A lot of people talk about Angular Material and Angular CLI and Angular Framework together just as Angular, but they are all separate independent pieces. And Angular Material is not the only framework that is out there. Not the only UI library framework that is out there. There's stuff based on Bootstrap, and I know other stuff exists in the ecosystem. But because Angular Material comes directly from Google, I wanted to sort of highlight it. And also Angular Material now releases are synced with the Angular framework and the Angular CLI. So often we get a whole new bunch of features at once. So why would anybody use Angular? And I guess this is my own opinionated opinion. So it has a very opinionated structure of how things are built, of how we build components, how we structure files for components, how the application is made, how like routing is handled, things of this nature. So this helps you when onboarding new team members. So if you're dealing with a big team, I really think Angular is a great approach because it helps with that onboarding. It helps new people come into a new code base and become productive quickly. When we're creating custom components, and custom components are basically our own our own HTML tags within sort of the Angular application. When we're creating these custom components, they have a clearly defined API, so we can define formal inputs and outputs, which helps with documentation, helps with reuse. There is a sort of a binding layer. Angular is based on a concept of two-way binding in a lot of places, and there's a lot of default stuff for HTML tag attributes, and then we can even build it into our own components if we want to. So that binding helps provide us with sort of a clear separation of display code and business logic. It's a dependency injection framework. So I assume a lot of people watching this are programmers, and that is, you sort of know what dependency injection is. We'll talk a little about it later, but basically it's just a way to share code among different elements of the application. And of course, I mentioned earlier, Angular is built to be testable from the ground up, and that helps us create better, more stable code. So install prerequisites. Say you're interested now, you want to build an Angular application. Angular is going to need Node.js and NPM, which you can sort of download and install from nodejs.org. And you'll probably going to want to install the Angular CLI as a global sort of as a global install to your computer. You don't have to, but that's the way I usually do it. But once we have the Angular CLI installed, and I am going to do this live, we are going to create a new application. Yeah, so I'm going to do ng new. Ng is referring to the Angular CLI, and this will spin up a brand new Angular application for me. What's the name? I'm going to name ITA for Intro to Angular. Would you like routing? Yeah, let's add Angular routing. A bunch of different CSS style sheets are supported. For the purposes of this, we're not really going to go into CSS at all for the purposes of this presentation, but I'm going to choose CSS. In client applications, I often end up using SCSS or one of the other CSS preprocessors. And then this is chugging, creating a bunch of files, installing NPM packages, and this is going to be the wait and see part. While I get a drink while this chugs. There we go. Okay, all created. So I am going to go ahead and let's take a look at what was generated. So we have node modules directory. which is, if you've ever dealt with Node, this is just the underlying libraries installed by NPM that use to make everything work. We have just a ton of configuration files, everything from linting to testing to the package JSON to an Angular JSON, which is a config for the Angular project. We're not going to go into too many details on that one, but I am going to take a look at the source here. So the source has a bunch of files, and I'm going to show you how Angular sort of uses these to sort of punch in the application. So index HTML is a default sort of HTML, and we can make changes to it. But what we really care about for the purposes of this presentation is this app root. And this refers back to an Angular component. And the Angular component, the app component, was created for us by default. So we have the app component CSS, HTML, spec file, which is a testing file, and a TypeScript file. So I'm going to open up this TypeScript file. And Angular makes use heavily of annotations or metadata. So we define this class as a component using this component metadata, and it has a configuration object that we're passing into it. This configuration object can specify a bunch of things of how this component works and how Angular knows how to put this component together to display it to the users in the screen. So I have a selector, app route, which this is basically the HTML tag that we've created. And as you could see it in the index, that's how it knows to pull up this component. There is a template file, which is an HTML file. And then there is an array of CSS files. So these are the different pieces that make up the Angular component, and they're all put together. I'm going to take a look at the Angular module, which is the Angular module defines a set of components. Primarily, there is only one sort of top level module, but you can break things into sub-modules if you need to. That's used for lazy loading with routers. And like if you're creating a library of components, you may want to separate them for easy import into multiple projects at once. So let's see. Declarations is in this ng module metadata that defines the components of this application. Imports is when we're importing other modules. So in this case, we have a routing module, which was generated automatically for us, and a browser module, which is just part of the Angular framework. Providers is providers or services, as they're often called, is something we're going to touch base on later. And finally, Bootstrap, which Bootstrap is only used on the app, the main app module. It basically says this is the root component of our application, and this is the one we want to start up from scratch. So that's the files that are created. Let's go ahead and run the dev server. So the Angular CLI includes, the Angular CLI does include a built-in dev server, which is really super convenient. And I'm going to go ahead and run it. This is the first time I'm running it because I've just installed the application. So it's compiling a bunch of things. It's generating a build. And then we're going to go load it in the browser. So boom, this is the sample Angular application. This is the default. And so boom, what the cool thing about this is I will demonstrate is it will automatically recompile hello JavaScript and friends. So I changed a file. I didn't go quick enough to see that modify, but automatically recompiled and reloaded in the browser. So it says hello JavaScript and friends instead of ITA. So let's go back to slides. So we created a new Angular application. We've looked at the stuff in it, the directories, assets is an environment. I didn't really touch on, but environments are different configuration different configuration options, and assets are intended for sort of binary assets. Often you may throw images and such in there. Let's see, you looked at the app module and the component, and I showed you how to run it. And that ends part one of this presentation. So we talk about what is Angular, why do we care, why we would use it. We want to build single page applications. We spoke a little about the history of Angular, starting with AngularJS, turning into Angular and the introduction of components, et cetera, et cetera. And we spoke about why we care about using it. And I showed you how to use the Angular CLI to create and run the default Angular application. So let's dive deep into Angular components. Now, I know we started a little late, so I was going to do a lot of this live, but I think I'm going to rely on my pre-built samples just for time constraints. So we're going to talk about what is a component, how we create one, how to share data between the component view and the class, how to respond to user interactions, and then how to more formalize our component by defining inputs, formalized inputs and outputs. So an Angular component is just a way to encapsulate code, encapsulate HTML, CSS, and TypeScript all into a single unit, into our single tag, into an HTML tag that can be used or reused within our Angular application. And really the way it separates the files, which I've sort of already showed you, the 4 separate files, the HTML file, the CSS file, and the TypeScript file, it gives us a clear separation of our code. And that's part of the things that I love about Angular, this clear separation. So what we're going to do is we're going to create 2 separate components, and we're going to use the Angular CLI to do that. And we just do ng generate. I'll do this one live before jumping into the samples. So I'm going to shut that down. Ng generate component view 1 and view 2. So super simple. I just created 2 new components. And here they are. And these components start out super simple. View 1 works, view 2 works. So let's go. I'm going to open the main app component HTML. I'm going to delete everything. Yeah, so I'm basically just creating view 1 and view 2, and I'm going to go back to ng-serve. And this will once again compile and run the development server. Much quicker the second time around. And we'll go back to the browser, and I'm going to reload. And view 1 works and view 2 works. So that's great. We've just created our own simple components. So let's talk about how do we share variables between a view and a class. How do we share values within our TypeScript and display those in the template? So I'm going to shut down my live sample and move over here. Sample 3. So we're going to take a look at view 1. So we're going to make this super simple. We are going to create just a variable on our TypeScript class named myValue, default value hello. And that's all it is. It's just a public variable on the class. And we're going to open up the HTML template here. And we're going to use this double curly brace syntax. That's the way we tell Angular that, hey, this is a variable, go get the value. So, and we're getting the value of my value. So it's going to say my value view 1, which is, I'm going to shut this one down. And yeah, we're going to run this. Hopefully this one goes quick on the compile too. It does indeed. Yeah, so Yep, and there it is, hello view1. So the variable we created inside that view template is now being used within the view. And this can, I'm using super simple examples here, but this stuff can become very powerful. Yeah, so let's let's go to next sample 4. Sometimes you want to respond to user interaction, such as a button click, and I'll show you how to do that. And that brings us to sample 4. So I added a button in here and do something. So because this button is going to do something within our application, I am using this special syntax, which is sort of parentheses. This means that Angular is responding to an event, in this case, a button click. So by enclosing it in parentheses, Angular knows when this button is clicked, to run this do something function inside the view component. So, and for the purposes of this sample, we're just going to log out something. And this is just a function like any other function within our within a TypeScript class or JavaScript class. So, and I'm going to do F12 so we can see in the console, when I click do something, we log out do something. So that's how we respond to an event or an interaction inside the view template from code in the class. So we spoke about how we got variables from the TypeScript class into the view template, and we spoke about how code in the TypeScript class will respond to actions in the view template. So let's think about how do we create something a bit more formalized for inputs and outputs, because basically we don't want to use pre-built like click events. We want to create our own events, or we want to create our own input instead of having to define everything inside the TypeScript class. So, and that is sample 5. So there is some special metadata for this. So I'm going to create the input, which is, I just put this input, my value in parentheses inside, in front of this my value. And that's just some Angular metadata that's defined as part of the Angular framework. And for the output, we're actually going to do the same thing. And we're going to create this output event, do something request. It's going to be of a type event emitter, which we create a new instance of. So by doing this, even though the value is hello, we can overwrite it if we wanted to. And this do something will create an event, our own event. And we are basically emitting that event and emitting some text there. So I added a log to something inside view1, so we can respond to the button click inside the view1 component HTML and sort of emit it, tell our parent component, the main app component, that we want to do something. So this is how we do it. We have my value as the input into the component. And by default, that value is hello. We are changing it to goodbye. These square brackets means we're passing a value into our child component. And the it's in goodbye is in quotes because it's a string, so it has to be an Angular expression that we're passing in. So this is a literal string. It could be a variable potentially, or even other logic. And then we're using parentheses to respond to our do something request and run this on do something in the main app component. So, and here on do something, I am just logging out inside app component. So when we run all this code, we can sort of see this running. What we should expect to happen is our default hello is replaced with goodbye, which is exactly what we see. So instead of using the default value, it was replaced by the component creating an instance of view1, the main app component. And when we click do something, we should see console log inside the component and the external one at the app component level, which means we listened and responded to this event inside view1 in 2 different places. And we just sort of bubbled it up to our own custom event. This is a sort of a common approach when building these Angular applications. So yeah, so a sort of quick review here. That this sort of ends the section on components. We spoke about what a component is and why we care. We're building our own HTML tag within our Angular application. I showed you how to create one using the Angular CLI to auto-generate it, which generates 3 classes: an HTML file, a TypeScript file, a CSS file, and a spec or a test file. I showed you how to share data between the view and the class, how to respond to view interactions from the HTML template inside the class, and then how to define formal inputs and outputs, which help basically create a formal API for people using our components in unknown ways. The next section of this talk, I want to take a look at services, or we call them Angular providers. I'm going to basically tell you what it is, how to create one, and how to use one. So a service is basically a singleton within the app. It is shared between multiple components or potentially other services using dependency injection. So Angular knows how to create it automatically when it's requested, or use the existing service if it's already been created, the existing instance. And it's just basically a class that has shared data or functionality among multiple components. So I want to make this clear. I was actually on an interview once with a bunch of Java developers, and they were interviewing me for basically a front-end position because that's where my interests lie. And I kept using the term services, but in their mind, they were thinking REST services, and it really led to some communication, which is not something you want on an interview. But Angular services is really, it's just a singleton within the Angular UI. It's not a REST service. It's not a server-side construct, although we often use Angular services to encapsulate the code to access the server side so that it can easily be shared across multiple components. But that's not inherently what I mean when I talk about services. So I've seen confusion there, so I wanted to make sure I clarify that. So let's create a service to share data. I'm going to generate it with the Angular CLI one. This time I'm generating a service. It's going to create 2 files, a service file and a spec file. And let's jump into code from there. So actually, I'm going to close everything from sample 5. And so this is the service. It has this injectable metadata. So, and it says provided in root. This means Angular is aware of this, and it's going to create this service, my service, as a singleton at the root level of the app. That's primarily how people use services, especially if they're app specific these days. If you don't want to inject this at the route, so for example, you're doing lazy loading or something else and want to control where it is generated, you would actually delete that and then list it in the provider array of the module, or potentially you can actually define services at the screen level. So nevertheless, we're going to create one value in here, my value equals default. And then we're going to do some things. We're going to use this service. So let's open up the view1 component. And this is the syntax to inject this service into our view1 component class. So we're naming it public service and then an instance of my service. So when Angular sees that, it knows they are requesting one of my services. So do I have an instance? If so, send it in. Do I not have an instance? If so, create a single instance and send it in. And under the hood, Angular just figures out what it needs. And it doesn't have to be public here, but it can be private if it's only used in the TypeScript class. But what I'm actually going to do, I'm going to create an input in my view1 component. This is just an HTML tag that you're probably all familiar with since this is a JavaScript conference. And I'm going to use this special this special Angular ng model. With this end, I spoke about sort of square brackets and parentheses before. This is Angular's two-way binding syntax because I'm using both of them. So when service.myValue changes, the input will automatically change. When the input changes, service.myValue will automatically change. So I changed view1 into a component for collecting data, and I'm going to change view2 into a component for displaying the data that we're changing within view1. So once again, in view2, I'm injecting the service into the component, and then in the view2 component.html, I'm using our double curly brackets to display it and just accessing the component, the service variable inside the TypeScript class, and then drilling down to the property myValue on top of that. So let's run this. And back to the browser. So default, as I change the value here, inside view1 component, it's automatically updated in view2. Hello, JS and friends. Thanks for attending my presentation. Yeah, so this is an example of how services or providers are used to share data between two separate Angular components. And things can get pretty complicated. Obviously, this is a 1-hour presentation, so I've kept things simple. Tried to keep my example simple, but in a real world application, things can get a lot more complex. So we looked at the files. So I'd only had the one sample for services. So we spoke about what one is. It's basically a singleton, shared data or functionality between two separate sections of an Angular application. I showed you how to create and how to use them. That is actually the end of the presentation. So I just have a few sort of review stuff here. So we spoke about what Angular is, why we use it, why we care. I spoke about sort of creating Angular components. I spent most of the time on that because that's what an Angular developer does for a lot of their time. And so I spoke about sort of the separate pieces of an Angular component, the HTML, CSS, spec file, and the TypeScript class. I spoke about how the TypeScript class and the HTML template speak together, both responding to interactions and sort of button clicks or other things within the Angular HTML file, and how the HTML template accesses variables within the TypeScript class, and how we can formalize our inputs and outputs. And then I spoke about services, which are providers, and how we use those to share data between Angular components or functionality. You can put methods in a provider/service also. So I do have a book with a ton of details on building Angular. They are designed for beginners. So just use the code JS and Friends. You can get 20% off. Learnwith.com. Please check out my stuff. Slides, I don't know if they're uploaded yet, but I'll make sure to get that done today. So I do have a GitHub with slides. I'm working on populating it with some of my legacy stuff. Slides and code, I should say. And finally, questions. Due to the nature of this virtual conference, we're not actually taking questions live as part of this, but there is a Slack place you can go questions, and I am in Track5. So I will be watching that Slack group for the rest of the day. I've muted it when I was presenting, but I will be watching it once I shut down here. So thank you everybody for hanging out and watching. And if you found the future recordings, thank you for watching it. And that's all I got. I hope you learned something, and I hope you understand why I love Angular.
So, hey there, everyone. Welcome to my talk called A Year in the React World. My name is Afonso, and before anything else, who am I? So, I'm a senior front-end engineer at Seracare. Besides that, I'm an Altiero ambassador, and you can find me on Medium, Twitter, and any other social network by the handle at Daniel JC Afonso. So, currently, the main ecosystem and stuff I've been focused on has been the JavaScript ecosystem, the React ecosystem, and pretty much everything related with the testing library. So what are we going to talk about in the next couple of minutes? Before anything else, it's important to mention that this is a real life case study that happened to me and the team over a year and a half while developing a React application. During this time, we had to discuss stuff like hooks, state management, and testing. So let's all make a time travel and just do a quick recap to 2019, something like that. And picture we were starting a new React project. What were the first questions and the first things that we should concern and be concerned with? Now, the first one was class components. So at the time, class components were still pretty much the foundation of React, and we all wrote React that way. But then something was appearing, something called React hooks. Hooks had been around for 5 to 6 months by the time we started our application. So when you're starting a React application in that time and you think, okay, should I continue using class components? Should I just move into hooks? You have to consider a lot of things. And there are a couple of concerns that I had and we all had with class components. The first thing here was giant components. So it was pretty easy to have enormous components in your code, and with related logic spread throughout the lifecycle functions. What I mean by this is, here we have this example that we want to do a subscription to a store. So, okay, I have to subscribe to the store during the component didn't mount lifecycle. But then how do I unsubscribe to the store? I have to do unsubscribe on the component will unmount. And what this means is that we have logic to do something that's related to a subscription to a store spread out throughout life cycles. And this would cause us to get a little bit lost the more your code grew and the more stuff you added into your life cycles. The other thing that was a concern was reusing logic. Now, at the time, there was no way to statefully reuse logic between React components. At a certain time, we had mixins, but then they were deemed unsafe. And then we had patterns like, render props or high order components, but those patterns usually led to something that we can see on this image here, which is called wrapper hell. So by wrapping every component with another high order component, then you have to wrap your high order component with another one just to make sure that you can pass logic between them. It would increase pretty much the size of your DOM tree and everything. And the best concern with class components was they're confusing. And when I say they're confusing, they are both confusing for us humans and confusing for machines. Humans, let's put into the perspective of someone who just started learning React. What do I need to know to use class components? Well, first things first, object-oriented JavaScript. We need to learn how to use this. We need to learn how to do event bindings. And these are things that come with its own complexity level. It's not that simple to get into the comfortable place with these things. And regarding machines, the React team has publicly mentioned a lot of times before that class components have some trouble with compiling code, and minification and stuff like that used to produce some weird effects. So putting this in consideration, we started thinking, so why not give hooks a shot? They are new. And besides this, React team had already said, hey, everyone, look, hooks are the direction where we intend to take React. So hooks are the future. Focus on hooks from now on if you can. And Okay, yeah, this is pretty good for to hear, and if you're starting a project, but we need to sell to our company that hooks are really advantages. And how do we do that? Well, we speak about the good things in hooks. The first one is code readability. So as you remember from class components examples, I told you about giant components. Well, with hooks, you can still have giant components, but with the addition of use effect, you can make sure that all your related logic is grouped under the same effect, and you can have multiple effects just to have that logic in there. So this makes sure that your code is even more readable and, yeah, pretty much more simple to understand. The second thing is code reusability. Remember me mentioning that there was no proper way to have a stateful logic share in React with class components? Well, with hooks and with the ability of creating custom hooks, this is now possible. We can share state between applications. We can share logic between applications in a stateful way by creating our custom hooks. And finally, the ease of teaching React. So in my team at the moment, we knew that we would be onboarding some junior developers in the future. And by not having to teach them all the constraints that came with React with class components, it would be easy for them to get into the React world and don't get lost into the confusion that it was React before. So yeah, we migrated to hooks. We started using hooks. But what did we learn? Well, the first thing is you got to pay attention to the rules of hooks. Like, you shouldn't use hooks in a conditional way. You should always add all your dependencies on your dependencies array, either on use memo or use effect. Because if you don't do so, then you're going to have some problems in the future. And you might seem it works right now, but in the future it's coming back to bite you. Trust me on this. So always pay attention to the rule of hooks. And if possible, just use an S-lint to enforce these rules for you. Then the second lesson that I learned was don't pre-optimize everything. So it's so simple now that we have used memo, we use callback to, yeah, let's just start wrapping everything. Let's put a use memo in here, let's put a use memo in there. And yeah, our code is now all memoized, everything is optimized to the top level, but at what cost? And this is what you have to put in perspective. Is it worth adding a use memo wrapping a string that will never change value? Is it? Or are you just adding extra code, extra complexity, making your code not as easy to read just for a simple thing? Consider that, because it's not in vain that it's said that premature optimization, it's the root of all evil. And finally, the biggest lesson and the biggest challenge was to stop thinking in life cycles. So when you come from class components, you're so used to life cycles, component did mount, component will unmount. And these are all rooted to your mind because your mental model is thinking in life cycles. And when you switch to hooks, suddenly you have to start thinking about effects. And how am I going to do an effect? And at the beginning, it was very, very hard to get rid of this thought. We would always be like, okay, so how can I do a use on mount hook for testing stuff? How can I? And until you got out of that mind constraint and create the new mental model of there's no more life cycles, there are only effects. And once you get into that perspective, everything is so much easier to understand. Besides this, we also noticed that junior developers got into the React ecosystem and learned effects so much faster and easier than us that came from class components because they didn't have the constraint that was life cycles. So yeah, this wraps the part of class components and hooks. So now I'll be leading this talk to probably the biggest topic in the React ecosystem, which is state. And when starting a project, it's inevitable that you're going to hear this question. How are we going to manage state? How will we do it? At my team, we decided to do the traditional way at that time, which was Redux. Yeah, let's just add Redux. Everyone's using Redux. The thing with Redux is it comes with a huge amount of boilerplate. The learning curve for someone that's not familiar with that type of model, it's trickier to understand, and you often find yourself in the need for middlewares like sagas, like tanks, and stuff like that to do other stuff. And using Redux on your application that it's starting right now, it doesn't have that much complexity. It's pretty much an unnecessary pre-optimization. I once heard, and I often say that using Redux in most applications is like using a bazooka to try to kill a mosquito. So yeah, we decided to move out of Redux. And how are we going to manage your state now, was the question. And someone answered, why not use what React already has? And then we went into context. Context is great. It was a very, very simple migration because we just basically decided, okay, let's use context with use reducer hook. So we already have our reducers built. We already have our actions. It should be a fairly simple migration. Well, the thing with context is you often end up with unnecessary renders. You often end up with related logic getting grouped into the same context, and it brings a bunch more boilerplate to your code. And this unnecessary renders question has been probably one of the biggest things I've asked myself when learning context. And this was the question that I've heard every single one that started learning context ask at certain time, which is, why am I getting unnecessary re-renders? So to understand that, I'm going to show you some code. So what do we have here? We have a random context, and we have a custom hook that will basically use the use context hook to subscribe to a random context. Then what we create is a random store, which will be basically the store for a context. And in that store, we have two state variables, something and other thing. We return something and other thing. And we also have an effect that every time that something is updated, I want to increment the other thing value to be something plus 1. Besides this, we return a random provider that takes any children and wraps them to be able to use our context. So how would we use this? Like this. So we have our component. Our component is wrapped with a random provider, which is a provider of that context. And inside of that context, now we can use the custom hook called use random context to get the variables from it. So in this example, I only want to have access to the something variable and to the set something function. Besides this, I want to have a console log to see, okay, how many times did my component render? So yeah, and we also have a button that when we click it, let's increment set something to be something plus 1. So if we consider the initial flow of the component renders, we click the something button. How many console logs are we supposed to see? Well, personally, when I didn't understand this topic, I would say only 2. One for the initial render of the component, and one after I caused the state update by calling the set something. The thing that happens here is that we are going to have 3 console logs saying I just rendered. And why is that? This is because every time React detects a change to something inside of its context, it triggers a re-render on all the context subscribers so that they can receive the new changes. And what does this mean for our application? What does this mean for our third console log? It's simple. It just means that a use effect run and the set other thing was called. So even though here I'm only calling something and set something, I don't care about the other 2 variables, they are affecting the number of renders that my application have just because they are on the same context. So how do we fix this? Well, there's a huge thread on GitHub about this, and this was the suggestions that Dan Abramov gave at the time. The first one is just split your context. If you want to have your only have access to those variables in your component, then why not create another store component, context, responsible for the other thing and set the other thing, and the second context responsible for something and set something. And this way, our component will only subscribe to this context and not to the other one. And when this something variable changes, then there will only have the two just rendered on the console. And usually this is the preferred approach. And if you're having this type of errors, you should probably see how can you abstract and remove stuff from your context, because yeah, it will mean that less free renders in this case will definitely be a better thing. And there are two more other approaches. The second one is split a component in two and use Mimo. So let's look at this example. We have our component. Our component subscribes to the random context. This is still the random context that has the other thing variable and the use effect. And then we have a button where we pass the something and the set something function. This button is a custom component that is wrapped with Mimo. By being wrapped with Mimo, it just means that the variables that it's looking at, something and set something, will be the responsibles for when does this component render. So only when there's updates to these variables, this component will render. So if you follow the initial flow, we have an initial render. So initial render, we go in here, something and set something, it's initial. So they had set up with variables. So they just log, I just rendered. Then we click on the button and cause a state update. This updates, something updates, and the Mimo looks at something and says, okay, update it. So let's go back inside and re-render the component and have a second console log. But now when the use effect kicks in, the one that will update the other thing variable, this context will say, hey, look, something in me changed, re-render. This component will re-render, but this component inside, since it's wrapped with something and set something, won't have to re-render because none of these variables change. So there will only be two re-renders inside of this component. And the last approach, wrap your return with use Mimo. This is pretty much the same approach as above, but instead of just having using the Mimo and the second component, you wrap the return phase of your component with the use Mimo hook and look at set something and something variable, and it followed the exactly same approach as before. So yeah, this answers the question of why am I getting unnecessary re-renders with context? So then we had another struggle, which was what's happening to our state? We started seeing a pattern, and this pattern led us to do some research. And we came to the conclusion that our state was comprised only of server state, instead of the typical global state that you expect it to have. So what do I mean by global state, you might ask? Well, global state usually is just referred as global state, the global state of your application. It's that concept that you have only one state and everything in your application access it. But actually, global state can be split in two types of other state, which is the client state and the server state. And what is each type of this? What is the client state, which is the server state? Well, the client state, it's the state that it's owned by your application. This state is temporary, local, generally non-persistent between sessions, and it can be accessed by using synchronous APIs. So client state is often called as well UI state. This is the state that you see probably in use state or in the use reducer. So this is the type of state that I'm talking about. And then on the other side, we have the server state. The server state is a state that is persisted remotely, usually on a database or something like that. This is a state that it's asynchronous, so we need to use asynchronous APIs to access it. And besides that, there is no guarantees that this state is always up to date. Besides this, server state comes with a ton and a ton of other challenges like caching data, background updates, deduping requests, identifying and dealing with outdated requests, and other things like performance optimizations and optimistic updates. So yeah, we looked at our context and said, everything we have here, every single thing that we have here is server state, everything. So are we sure that context is the right thing for us to manage server state? And we came to the conclusion that it was not. There was something new in the market. There was something new, a new library that would help us manage server state in a much more simple way. And that one was called, and is still called, React Query. React Query, as I like to say, is a protocol agnostic collection of hooks for fetching, caching, and updating server state in React. And this is pretty much what we have been using in the past 2 years or year and a half or stuff like that. So this is the best way that I know of to manage server state. It's so good, it's easy to use, and makes it so much simple to handle this type of state. So yeah, it should be fine by now for us, right? Well, the thing is, after a couple of months, we started to notice that we had some use cases that we actually needed client state. We had the need for the UI state. And were we going to go back to context? We didn't want it to go back to Redux as well. What should we use? We wanted something that would be simple, but had an easy learning curve. And this is when we met ZooStand. So ZooStand is a hooks-based API that has an easy learning curve. It allows you to have transient component informs, which means that it won't cause a re-render to inform your component that some variable updated if you choose so. This is completely optional. And there's no need for context providers. It's as simple as create a custom hook that creates a store, access that store, and you can use it all over your application. It's so simple to use and easy too. And this is how I've been managing state in the past years: React Query and ZooStand. And they are such a great combo. So this wraps the state part of this talk. And now we head into the more fun part, and the thing that usually I can get more lost into, which is testing. So doing a quick recap, remember at the beginning of the talk, I said, okay, we migrated from components, from class components to hooks, right? Yeah, we did. Everything apparently went well. Like we had almost half the lines of code we had previously. Everything seemed seamlessly okay. But then someone remembered, hey, have we ran our tests? And we did. And this was what happened. So you could probably imagine that this was our reaction. We were left to wonder, so everything is working as it was before. The user experience for our application is the same. Why are our tests failing? Well, we did some research. We needed to find the guilty party and needed to know what happened. Why are our tests breaking now? And we did. And the issue here was testing implementation details. Now, what are implementation details, you might ask? According to Dots, implementation details are the things which the users of your code will not typically use, see, or even know about. So putting this in perspective, and let's think in React components, hooks are things like state, props, class attributes, ID attributes that we add to our components. The user doesn't see and care about these things. And yeah, these are implementation details. And we look at our tests that at that time were being written using Enzyme, and we just saw implementation details everywhere. Everything we saw was tests talking to implementation details. And it was pretty clear to me at the time that we needed to stop using Enzyme. Why, you might ask? Well, before anything else, let me say, Enzyme is great. It gives you a bunch of tools and allows you to write your tests well. The thing here is, if you don't know, or if you have some misinterpretations of stuff, Enzyme will probably end up used in the bad way. One of the first things that I don't like about Enzyme is shallow rendering. So for those of you who don't know, shallow rendering is the way that you render only the shallow part of the component. So if you have a component that's a parent, this component is a parent, and it has some children inside of it, it will only render the parent part. The children won't be rendered. And let's put ourselves into the user mindset. When I'm interacting with that component, am I interacting only with the parent component, or am I interacting with the parent and with the children? Yeah, I'm interacting with both, right? So probably shallow rendering shouldn't be the way that I want to use to test my components. The second issue and concern I had with Enzyme was the way it allowed me to query for stuff on the DOM. The first one was it allowed me to search for component names on the DOM. If I had a component called foo, it would allow me to say, okay, hey, find foo on the DOM for me. And this is very powerful. It's amazing. But imagine that you have to rename your component. Then this test will break immediately because you're focused on implementation details. You should always try to look for stuff on the DOM the same way that the user looks for. How does he find the button? Well, usually he looks at the button and he clicks on the button. So he searches for a button on the DOM. He doesn't search for the class name btn or for the ID attribute submit button or whatever. He just searches for the button and clicks on it. And finally, one of the things that I personally dislike about Enzyme was state. State was the way that Enzyme allows us to access the current state of our application. And once again, let's think as a user. As a user, if I click on a button, I want to know that if a pop-up is going to appear to confirm me that. I don't really care about if I click on the button and the current state of the Boolean variable is open is true. So by tying our tests into the component state is basically, just wrapping it to your biggest implementation detail. You're not testing the way that the user uses your application. And when we decided to move out of Enzyme, we found out the best thing for testing React applications, which was, and still is, the React testing library. The React testing library was created by Ken Dots, and here its main guideline, which is the more your tests resemble the way your software is used, the more confidence they can give you. And this is amazing. And I could speak about the React testing library for hours, but that's subject for another talk. I'll just give you a little glimpse of things that it allows you to do. First things first, it promotes accessibility by giving you queries that are accessible to everyone, like query by role, which will query stuff by ARIA role, query by label text, query by text. These are the queries that mostly reflect the experience of visual, mouse, of assisted technology users. And by focusing first on this type of queries, you always be thinking on, how can I make my component more accessible? Is this good enough? Would a user using a screen reader be able to interact with this component? And just this perspective is an amazing thing that you can have as a developer. Second thing, the React testing library lets you create your own queries by using the build queries helper. This is very great, but careful, because if you decide to follow this approach, it's important that you create queries that focus on the user-centric perspective and not on implementation details. Then it also allows you to do user-focused events. So by using the user event library, you can literally simulate all the events that the user does in this scenario when clicking the button that has the name save. So when you click on the button, there are a couple of events that are triggered: the on mouse over, on the mouse down, click, mouse alt, and stuff like that. And the user event library will literally simulate all of these events for you. So you will have the entire user experience when testing stuff. Besides that, you also have an amazing set of asynchronous utils. You have wait for, which is a function that allows you to wait until your assertion is validated or evaluates to true. And you have the wait for element to be removed, which allows you to wait for something to disappear from the DOM. So right now I've been using the React testing library for over 2 years, and here are the most common mistakes that I've seen people doing with it. And it might seem a lot, but we're gonna go by one and just see how it goes. The first one is using act. So for those of you who don't know, when interacting with the user interface, there are things like rendering, user interactions, data fetching that are called units of interaction with the DOM. Act is an util created by the React team to make sure that all these units of interaction with the DOM have been flushed and complete before you continue your test. So putting it in perspective, it would make sense that, okay, I'm rendering my components, so let's wrap that in act. I'm firing an event, so I'm interacting with the DOM, so let's fire an act. The thing here is, you don't need to do that because React Testing Library already wraps every single function and stuff that will cause some units of interaction with the DOM with act for you so that you don't have to do it. There are almost 0 scenarios that you need to use act on your daily basis. Using getBy, we expect not to be in a document. So we didn't delve into queries, but getBy is a query that React Testing Library gives you that will either find the DOM node you're searching for, or it will throw an error. And in this scenario, we are using an assertion, which is, okay, I don't want this to exist on the DOM. Assert that this doesn't exist on the DOM. So if I'm using this query with something that will throw an error when it doesn't find what's looking for, what does this mean? It means that our test will always be failing. So how do we fix this? We use the query by variant. So while the get by variant throws an error when it doesn't find what's looking for, the query by variant will return null when it doesn't find what you're looking for. And this is the best query to use to assert that something doesn't exist. Yeah, another error that might seem pretty simple, but I've seen it a lot, which is using await with firing events or non-asynchronous queries. So here we are waiting for a query of getting a button. And then here we are waiting for firing an event. The thing here is none of these functions are asynchronous. They are both synchronous. So let's just remove the await from there and move on, okay? Using await with wait for with an empty callback. So I didn't delve too much into this, but as I told you in the previous slides when I mentioned asynchronous utils, I told you that the await for will wait until the code inside of it validates to true so that your assertion is completed and can continue your test. What we are doing here is we are calling wait for with an empty callback and then asserting that our mocked function has been called. Now, this might pass sometimes. This will cause you a flaky test because basically what this will do is it will wait for the next tick of your test and then continue. It won't wait for this assertion to be called. So what should you do here? Just pass that assertion inside of wait for and wait until this assertion evaluates to true. Pretty simple, right? Cleaning up. Well, we all want to clean up after we do our tests. We don't want tests bleeding into each other. We don't want to have side effects from one test to another. So this in React, this usually means, okay, after this test, I want to clean the DOM. I don't want anything more on here. So we could use the cleanup function that the React testing library offers us, right? Well, if you're using Jest or any other framework that supports the after each global, you don't need to because the React testing library will automatically do this for you. It's that simple. Using wait for with synchronous queries. Well, as I told you a couple of seconds ago, wait for will wait for something inside of it to evaluate to true. So here we are waiting for our progress bar to appear on the DOM. Well, we don't need this. Why, you might ask? Because the React Testing Library has its own asynchronous query, which is the find by. So instead of using wait for with query by or get by, why not just use find by and use the right query to do? and the proper way, basically. Using side effects inside of wait for. This one, I've seen it happen a lot and usually can take you a bunch of time to figure out that you've done this mistake and rip a ton of hairs. So what we are doing here is we are waiting for this user event to happen. So we wait for a click on the button with that has the text save on it. And then we want to wait for this assertion, this mocked function to be called with form data. The thing in here is, remember when I told you that the wait for will loop the code inside of it until it evaluates to true? This is what will happen. So basically, it does the first loop. If it gets here and this assertion evaluates to false, it will loop it. So once again, you will be clicking on that button. And this might cause unexpected side effects on your components and break your test and do stuff that you don't want it to do. So what should we do? Simple. Just do your user effects and your firing of events outside of the wait for, and only use wait for assertions. As simple as that. So yeah, this wraps the main mistakes that I've learned while using the React testing library. Before I finish my talk, I just want to talk about something that's very, very important and has given me tons of headaches, and I've seen questions and questions and questions and tests full of it, which was not wrapped in act. This is a warning that appears sometimes in your React tests. Basically what it says is an update to app inside the test was not wrapped in act. Remember act? When testing code that causes state updates, this should be wrapped into act. So, but wait, Daniel, you said you shouldn't be using act in your tests. Yeah, I said, and I still mean that. Let's look at this following code. Here we have a function which is called a component which is called display Pokemon. This is a component that will receive a function called get Pokemon data, which is an asynchronous function that will be responsible for fetching our Pokemon information. We have a use state variable that it's called isLoading, and it's initialized as false. So it means that by default, it won't be loading anything. We have our get selected Pokemon function, which is an asynchronous function because it will have to wait for the get Pokemon data to return the promise value. So what it does is when you get this function, it sets the loading as true. So the state variable is true. Then it tries to get the Pokemon data. Once it finishes, it sets the loading as false. If there is an error, it also sets the loading as false. On the render part, it just returns a div with a button that on clicked, it will get the selected Pokemon, which is in this scenario is Pikachu. And we have a span that will show you when your application is loading or fetching new Pokemon. So how do I test this? You might wonder. Well, a couple of months ago, I'll probably do this. Here we have a test that it's titled should call get Pokemon with Pikachu. So this test, what it does, what we do in this test first is we have a const variable, which is a mocked function by using just fn. And we pass this mocked function into our component that we use render from the React testing library to render. Then we click on the button that has the text Pikachu. And once that's done, I want to assert that the Pokemon data was called with Pikachu, right? So yeah, the assertion should be done. It was because this is what this does. I click on this button and this calls the get Pokemon data with the Pokemon name. So yeah, this is my test. Everything, I'm testing the scenario. It's working. But then we get this guy back. And the error is here again. An update to display Pokemon inside the test was not wrapped in act. When testing code that causes wrapped state update should be wrapped in act. And damn, this error is annoying. It made me lose my mind tons and tons of times, and until I finally understood what's happening. This warning is basically the way of the React team telling us that, hey, look, you coder, you haven't tested everything. you forgot about something in your test scenario. You are testing part of your interaction. There is something that it's triggering a state update that you are not considering. And looking back at our code, what state update might we be forgetting? The set is loading, and it's as simple as that. Basically, what this warning is telling is, hey, look, you are searching for your Pokemon data, but you are forgetting that there's a state update being caused by the set is loading. And basically, your test is ending, but when your test is ending, there's a state update that is being called. So before anything else, let's thank the React team for this warning, despite being annoying as hell when you don't know what you're doing, but thank them because now we can write a proper test. And what do we need to do right now? Pretty simple. So we just need to either wait for the loading text to no longer be on the DOM. So we just wait for it to disappear. Or then we actually use the wait for element to be removed with the get text loading. So this will wait for the loading text that shows up on the span to disappear. And by doing this, it makes sure that it covers our entire test and everything is okay. So yeah, I guess that's it. This wraps my talk. This was an amazing adventure. It was over a year in the year and a half of learning about React. And there are tons and tons of other things that I've learned, but we don't have that much time to share it with you. So these are the ones that I found more appropriate, I guess. So once again, thank you so much. My name is Daniel Afonso. You can find me everywhere at Daniel JC Afonso. If you have any questions, feel free to hop on the Slack channel at Track5 questions and leave them there for me. Thank you to the JavaScript and friends to having me here. It was amazing. It was an amazing experience. So once again, thank you everyone. Have a rest of a nice day and hopefully see you next time. Bye.
Test, test, test. Okay, let me double check that I'm actually live. Oh, okay. So just give me, heads up when it's actually live, and I should get started. Okay. Hello, hello. Okay, let's see. See if it's actually live. Let me go to YouTube. See if I am live already. See. Track number 5. Oh, actually, I am live. Test, test, test. Okay, great. Okay, I am live. Okay. Thank you, everyone. Sorry for the confusion and all, but let's get started. So today I'll talk about open source project health. I currently, just to give you more understanding of my credentials, what I currently do, so you know that me speaking about open source kind of makes sense. So about me, really briefly, I'm an open source developer advocate at Facebook, where again, we have an amazing website, Facebook, opensource.fb.com, where you can find a lot of content that we produce about all sorts of projects, whether they open source projects from Facebook or others. So we, as I said, produce quite a bit of content around that, and I invite you to actually watch that. Sorry about that. I focus on mobile for the most part, like Android, iOS, and hybrid, like React Native. So those are my focuses. As I said, it's React Native, projects like Litho, Fresco, and Flipper for debugging, React Native and other mobile apps. It's basically what I do. I apologize this morning. I have a sore throat, but that's how it is right before the presentation. All righty, and last but not least is I am passionate about open source. From years of working with open source projects, I realized that if anything, the desire to actually work with open source, contribute to it, and see the purpose behind it is what matters the most when dealing with open source. So fortunately, I have that passion, and I hope you do. So Facebook open source, more broadly, what I'm going to talk about is open source. It's not going to be tied to Facebook as much. It's just the learnings I had. Always, need to update the desktop while I'm presenting. But anyways, I'll talk about open source as a whole, and hopefully you can, get some takeaways and apply it to your projects. So what is open source at all? If I were to define it more concretely, people say it's a process of making technology available to others to use and improve. Kind of a very rigid definition, but it is true. If I were to write it on paper, that's probably what I would say. But in reality, what matters the most is, why do we even care? Why would we contribute to open source to begin with? And first and foremost, it's all about the community. It's the culture. It's the getting people from all over the world, from people with different backgrounds. I worked in the past with folks who are anthropologists, who are actors, who are writers, developers. I myself come from the background from medicine. So it's it's all those different backgrounds and insight that people can bring to the table is what makes open source exciting, and why your contribution matters the most. Leadership. If I don't want to be naive either, individual contribution to open source is extremely important, and I can't emphasize it enough. But at the end of the day, for the most part, large open source projects, because they require so much time to be maintained and worked on, need to have some backing. Sometimes need to have some backing from the corporation of some sort, or large organization, or multiple organizations, or foundation. And but one of the reasons why they do it, because it's important to ask why, it's for the leadership's sake. They want to be a leader in the space they are contributing to. For instance, in mobile, I work with mobile open source. I want to be perceived, myself and the organization, as one of the leaders in the mobile space, in the web space, in case of React, or AIML with PyTorch, or in case of Google, it will be TensorFlow. We all do that for this. One of the reasons is we want to be a leader and be able to play a major role. It's also a big reason why people contribute to open source is the productivity. When you interact with organizations or with individuals on a private level, with NDAs signed, plenty of legal red tape, sending code through, I don't know, sometimes it's private repos, sometimes it can be as old-fashioned as emails or FTP. So when it's actually open source and it's in the public domain, or it's in the public for people to consume and work with, or even read and check, especially in the for security open source, it matters the most. But anyways, because it's all done in public, that collaboration in open source is done in public, we get to be more productive, because the feedback loop, the loop between you doing something and getting the result that it's working, it's meeting all the use cases, because you yourself or your team can't possibly guess all the possible scenarios that your users will do. In the past couple of years, I really enjoy seeing how important accessibility becomes to the open source, and it wouldn't be possible without really contribution from folks who interact with those who need accessible features or who need the accessible features themselves. There's definitely a bias when software is closed. When it's open, really, it brings all those people and makes it more productive for everybody. And again, I don't want to be naive, or, I like to be transparent. Branding is important too, whether it's a company or it's a person. I know so many folks, not on open source itself per se, but even if you go on Twitter, those people who become, like you can say internet famous, but in reality, it actually goes down to what contracts they get, what freelancing jobs they get. And branding and how they work with open source matters, because again, it's usually free. It gets you to share your knowledge with people. It gets to contribute to open source, and branding matters a lot because ultimately it brings value to you. And if you want to learn more about, like in a short version, what open source is, there's a video on our Facebook open source YouTube channel where you can learn about open source in just under 2 minutes. But I've talked about why contribute. The question is how to contribute. And obviously, the source code, actually coding something, is what comes to mind first. It's a developer that we see that has a great track record on GitHub, and we think that, okay, I have to be a coder to contribute. It is not true. All the contributions matter. Contributing to documentation, fixing typos, all of that is essential. Code without being documented or maintained on documentation side is useless. It becomes a legacy code. Nobody wants to touch it. Nobody wants to change it. So documentation is as important, if not more, than the source code. Translations. I've in the past, when I was just starting with open source, I was hesitant because it seems like it's the massive ocean of information. Just the building of the project itself took me days and days out. And be able to just translate documentation from English, let's say, to my native language, Russian, helped me to start because it gives you that confidence. The small wins, the small changes, give you confidence boost that makes you, it removes that so-called imposter syndrome, or at least helps you to deal with it. And you can try documentation fixes, source code fixes, etc. And the last but not least is testing. Testing. Your code might look nice. It might have great patterns, design patterns, amazing architecture in place. But if it's not tested and it's not verified, and you just let, your CI deploy it, nobody's going to use it. If it's going to fail constantly, it's going to hang on users. You need to have a proper testing in place, whether it's automated testing or people doing experimental testing as well. UX testing, all those things, you do need people for that. And it's as important as anything else when it comes to contributing to open source. And again, there is a great video from one of our developer advocates at Facebook on how to contribute to the open source for the first time. It's a bit longer video. It's about 10-14 minutes long, but it really covers, gets you from, as they say, from zero to hero. in terms of contributing to open source. But I obviously had quite an introduction to open source here. It's already on slide 29, and it hasn't been long. So what are we trying to achieve with this presentation today? What I'm hoping to achieve and talk today is about open source health in terms of like really what are we looking for in the open source projects, how to improve them, defining those gaps and hopefully covering them. I hope to again provide the guidelines for open source. Maybe it's for your team, maybe for your company, maybe for your individual project. And lastly is the main idea that I will be trying to bring throughout this presentation is the fact that communication is the key. Communication matters a lot. I want to make sure I am still live. Okay, I think I am live. Okay, good. Okay, so Facebook open source. As I said, I work with Facebook open source team, but these are actually metrics that we define that defines all open source health across all 600 or 700 projects that we currently have in the open source portfolio. Unfortunately, there is no such metrics. There is no silver bullet that can be applied to everything. It always depends. As any consultant will always say that phrase, it depends. And so there is some metrics, obviously, and in some potential health data is repo numbers, you know, how many people used it, how many people forked it, how many stars you have. That's all great. But really, you can't just go down to the numbers and expect to assume that your community is healthy, your project is thriving. That's not enough. You can go beyond that and, you know, go to Reddit, Stack Overflow, some other Q&A forums, even Quora potentially. But again, it might be not enough. It's just one part of the puzzle. Twitter and YouTube, that's a bit better because there you hopefully have a proper dialogue with your actual community, because on Twitter, ideally is when you share news, but you also have the back channel for people to ask you questions, work with you. With YouTube, you get to share the content that your users want to see, your community wants to see. If they have a question how to build the repository, you get to answer that in the YouTube video or in a blog post that you might write. And also there's a thing called Orbit model. It's a website, orbit.love, I believe is a URL. And I also will share URLs along with the slides after the presentation. But I think it's a great initiative in the space of where I am. I'm in developer relations, but ultimately it's trying to build this connection within open source. It gives you quite a bit of metrics like user 1234 made their first contribution, made the first commit. Give them props, give them maybe a badge on their GitHub account, give them kudos, or you can track all sorts of metrics. And I think Orbit, again, it's a great initiative and things to track in terms of startups that try to orient themselves at open source, but also find the way to collect the metrics, because metrics has always been complicated, especially in open source space. But again, numbers is one thing. I don't want to just look at the numbers of questions asked or number of stars. It's really about conceptual approach, and this is what I'm going to talk about. It's these guidelines I'm gonna give you. I'm not able to give you a prescription saying you have to have 100,000 stars on a GitHub to call it perfectly healthy. There are many projects that can have thousands of stars, but in reality, they don't have a code of conduct, or their community is 0 to none. You know, people are excited to see it, but nobody wants to use it. Nobody wants to contribute because it is hard. So how do you fix that? How do you make that contribution pipeline healthy again? And these are the guidelines I'll try to cover today. And again, it's not about just Facebook. Even though I work for Facebook open source, it's really thinking about just large scale organization. So I will be keeping in mind the larger scale open source projects, or at least the communities. So keep that in mind. But if anything, I think these guidelines are applicable to most of the projects out there. But in general, there are 5 types of open source work in terms of improving your open source projects. And these types of work are planning. You have to plan what you're doing. You know, I think there's a great quote that I don't remember, is that something like action without a plan is meaningless. someone else said it much fancier, but ultimately that's the core idea. If you're trying to walk without a map, you're probably gonna get somewhere, but you might encounter some bumps around, along the walk. Having a proper plan, knowing exactly when your project is considered to be successful or not, when to sunset or archive it. This is important to know. Branding, how do you brand your open source projects? How do you bring adoption for the project? Documentation, as I said, documentation is not any less important as anything else for your project. And the code base, how do you make it so it's welcoming? All those memes about IT where first it's only you who know how the code works, and the next day no one knows. All those memes always make me sad. That shouldn't be the case. There shouldn't be silos in the code, especially in open source. It should be welcoming. So there are no gatekeepers. People can come in, they can figure out how things work and contribute, make it better, and be proud of themselves. So let's talk about each of these types of work a bit closer. When it comes to planning, you want to know why you do open source. Just doing open source for the sake of open source is the worst idea you can have. It's not enough reasoning. You have to know exactly what the goal is, and possible goals that as being a developer advocate, when I work with a team, it's one of the first questions I ask. Why do you do what you do? Why are you thinking of open sourcing? And I give them some options for them to go back to the drawing board and come back to me with the answers. And one of the goals that in organization, I said, I'm talking about quite a large scale, but still, one of the questions and reasons why companies might open source something is recruiting. It's not like we try to recruit and say, work on the open source, but we do tell people, let's say that there is a opportunity to work on open source. You can see the technical capabilities of people at the organization that produce this open source initially, and you can see our culture of open source and communication externally as well. So that's just a great tool. And if that's your goal, great, but be clear about it. Is it that you're trying to improve your open source projects and you are looking for contributions externally, and you are going to bring those contributions back to your team, to your project, to your organization to make it better? If you just thinking of packaging it, sending it out there in a read-only format, which is common, let's say, in the research space. People often share, research paper, research the code that goes along with it, and that's about all. It's out there, it's read-only, not looking for contributions, and it's not bad. It's just you have to be clear. You don't want people to send you pull requests and leave them hanging for days, weeks, and months, and years. You want to be, responsive. You want them to know exactly what to expect. So be clear if your contribution is what you're looking for, or something that you're not looking for. Branding, if you're trying to brand yourself as an open source organization or open source as a whole, it's just a great way to leverage a positive side of things. For instance, if we talk with open source at Facebook, you can say that React, that again was started at Facebook, just think about how many jobs it started, how many organizations, how many startups and actually big companies are using React, how many jobs it produced. That branding alone, that notion, that narrative helpful for any organization if you think about it. And again, adoption, maybe you're not looking for contributions as much, but you are looking for adoption. And so if you have that plan in mind, have that documented. So say that you are looking for minor contributions, for instance, but the major changes, the architecture changes, the roadmap will come from within. Make it clear. Trying to adopt, but not necessarily change it. If you want to change it, tell your users, your community that please fork it, make your own change, and have a separate branch of our open source. So be clear with that. But always think long term. It's all about thinking and having plan, and also very important that your team has to commit to that. I don't want to just talk to a manager of a team and tell me what the goal is. I wanted to go back to the team after I introduce them to potential goals and check with the team. Are they gonna maintain the project? I don't want to just have a project thrown at the wall and hoping it will be picked up. check if they are committed to it. Do they have passion for it? Do they even care for open source? I don't want to just open source it because someone is looking for making their work public, might look nice. If it is, there are other avenues. You can open source under your own profile. If it, your company allows it, those things are possibilities. Just think about in the long term. But more, just to wrap it up, whenever you open source something, it's like a life cycle. You have to think if something gets born, something's going to die. The same goes for the open source projects. If you're thinking of open sourcing, think of how you're going to, wind it down, wrap it up. What is your end goal? Is it to move to foundation, make it self-sustainable? Is it to archive it after someone comes along with a better project and maintaining your project is not feasible anymore or doesn't justify the cost? So think about it. Have the return of investment planning as well. When it comes to branding, it's not just about marketing alone. It's also about showing commitment. You're not just thinking of let's run ads about the project. You are thinking of how do I show to the public that I am, as an individual or maybe as an organization, as a team, care about project. The users who will not just use it, they will contribute back to it. How do I show them that it's something to spend any time? Time is money. Time is so valuable. Time, you can get your time back. And so I don't want people just to waste it. So I want to show our users, our user base, that our audience, that the project, we are committed to it. So how do you show that really? That's what branding comes along. How you name your project. If you name your project open source project 1, 2, 3, 4, it's most likely, people will see that you just don't care yourself. You don't care about it at all. Logo might be, doesn't have to be well designed by a professional designer. You might, in the future, you can iterate. We have a great project called Docusaurus. That's one of the projects from Facebook. It's a static generator website tool where, even our opensource.facebook.com website is built with Docusaurus. It's a great tool for anybody who's looking for quickly building the site. But why I'm talking about it is they initially had a very nicely hand-drawn logo for Docusaurus. It's like a dinosaur, but drawn by someone like myself who is not, that doesn't have maybe as many artistical skills like I don't, but it actually is very, very nice and funny. But today it's looking proper and very like fancy, dinosaur-like. So iterating on the logo is fine. Even on the name, it is fine to iterate. Our project Flipper used to be called Sonar. Iteration is fine, but show that you cared, show enough that you thought about it. When people see a logo at the project, they know that you spent more time, maybe even money on it. And so it shows again that commitment to the project. Narrative. You have to have a narrative. You can't just do things because you want them to. It's again goes back to the planning. You have to know what I'm trying to communicate. If you have a project about MySQL, if you have a project about, I don't know, C, if you have a project about AIML, all those under your one organization, without actually having a common narrative, what you're trying to achieve, your users, your audience will think, I don't know what this company is thinking. I don't know what they're trying to prioritize. Make it clear that all those 3 projects are towards a common goal of, I don't know, making developer experience better for DBAs. Think about it. Think of your narrative for what you're trying to achieve. And social media. It might be, we have to admit that if you are in tech, Twitter, for instance, is a great source of information for technical stuff. Or if you can go, you're going to Reddit for some other questions, or Eli5 sort of AI or Ask Me Anything sessions with developers. Web space has a great Reddit communities as well. You can go to Quora, you can go to Stack Overflow even, but you have to have those places for your project or for your organization, something that people can follow. Because people don't want to go to GitHub and sign up for watching your project. or sign up for elsewhere. If they already have a Twitter account, send them there and let them follow your project for any updates, any new releases, because people will see that you care. And also you get to, buy, or not to buy really, but reserve the domain or reserve a name at the Twitter or elsewhere early before you even open source the project. So think about it ahead of time. Documentation. Documentation is one of the cornerstones of open source. It's very clear. I can't make it clear enough, especially because of my presentation is only for 1 hour, even less because I'm hopeful for Q&A. But documentation is essential. It's something that makes or breaks a project. If I'm a user, brand new audience, especially those who try to use it or contribute, I can't just look at the code alone. I can, but it takes too much time. I don't have that sort of time. So to simplify that, to answer those frequently asked questions, you have to have proper docs, proper maybe a website even. The documentation is great for contributions. You have to explain those, how to build, how to log a bug. It makes it searchable. If you're looking for an answer, that's why Stack Overflow was so powerful before. Even now, you could find almost anything about anything at tech. Often, if anything, we did at Facebook Open Source a small study. It's kind of unofficial, but if you look at the top GitHub projects, you'll see that majority of them have a website associated with documentation. It's not just on the README on GitHub itself. And there are simple tools like DocuSource or Jekyll that are free to run. You can use GitHub Pages for, but it will have a nicely formatted, nicely looking website that it's fully cross-platform functional. You can open it on your phone, on your tablet, on your desktop, and you can read if you need to read on a road or elsewhere, anything that you need to read about the project. So it's very useful and handy. Alex.js, just a thing I want to say about documentation. Alex.js is a project that it's like a linting tool that looks for words that are not welcoming, to say the least, inconsiderate words. So check it out, maybe run your projects against it and see where your gaps might be and fix them. Or if you're looking for first-time contribution yourself, run some projects documentation through Alex.js and suggest those words to be removed. It's words like easy or simple. It might be simple for you because you're working with a project, but it is not simple or easy for someone who's never dealt with it before. So even those words might be questionable. And so Alex.js is a great place to start. And lastly, it's a code-based work. And the reason why I brought it to the end of considering different types is because it's so obvious is where it all starts and what we always think about first, code. But I always argue that code is kind of the last thing, really. You have to have a code of conduct. You want to have a diverse and safe environment for your users, for your contributors, for your base, and that's where code of conduct helps you. Most conferences today, if not all of them, hopefully have code of conduct because it makes sure that we have a safe environment. README, it's also a place where everybody starts with when you go to GitHub or GitLab. And that's where you will spend time documenting the core ideas, what it is, why it's been built, and how to build it, how to contribute. That's where contributors times come along as well. It's a bit more intensive, more has more explaining into exactly how to contribute and how to file a bug or an issue, but it is important to have. And when it comes to PRs and issues, let me see. When it comes to PRs and issues, always have a template. GitHub has a great integration for you to create a template for if, let's say, someone files their first PR or second or third or fourth, it doesn't really matter, pull request or their issue with the project. There's nothing more time consuming and wasteful, I would say, than someone filing a bug saying this doesn't work. And then the follow-up question from the owner of the project or whoever contributes to it they ask, how did you get it? What's the repro steps? What is your environment? Give us logs. Questions that should have been explained and answered before the PR or issue was filed. So have the template, which will, when someone tries to create a PR or issue, has to fill out like a questionnaire, like a form. What are you asking from them? Like, you want to have a repro case. With the best scenario is like test failed, right? With test, you want to say what expected, what the actual result is, and how to reproduce. That's it. Have that template in place so anybody can fill it out. And last but not least is community work. It has to be team driven. Really, you can't just expect and hope that someone else's work will handle community interaction. Your team, the team behind the project, has to work on communicating with your community, answer questions, be responsive when someone asks how to contribute. That's where documentation comes along, or even YouTube videos or some blogs that have the frequently asked questions in place. They explain where to go, how to build. All those things simplify your work, but it has to be team driven. We always have on call for open source projects as well. So I know which team to ask if there's something wrong with the project. That's where content is so important, because that's where people can be sent to, because you don't want to be a person behind it every time answering all those questions, because they're repetitive, especially at the beginning. That's where it matters to have those beginners, because the beginner is like, it will be reproducible. The next beginner will have the same exact questions, maybe similar questions. Try to document what you answered to someone else, write it down, maybe in the README, maybe write it on the website, wherever. Have that written for the next person, for your community. Have a community space so people can ask questions. Like for this conference, we have a Slack. You can have plenty of other ways to interact. Some people actually just exclusively use Twitter. Some people use Google Groups. People still use email lists. Lots of places to interact, but you have to build that community space so people know where to go and where they can congregate. And don't forget, communication is the key. If there is anything wrong with the project, the first thing I look is, what has your communications been like? If you don't talk to them, if you just being abrupt, you just close issues without explaining why they're closed, this is not going to be taken lightly by the community. Always talk, whether it's in live or with the open source. So that is important. And with any of my talks, I always like to finish them by doing some call for action. And so focus on communication throughout your open source work. Never leave it behind. Know your community. Try to understand them. Have many teams, actually, even an open source I see, they have something called office hours. Have an office hour. You can use Twitch, you can use YouTube, you can use Slack, whatever you use, so people can ask questions and get to know you. People like to put faces to names and voices behind just their profiles. So know your community. And even though I said metrics is complicated, but don't give up, right? Give it a try to collect it. And if you really want to talk to me more about this whole open source metrics and the health measurement and how to improve it, please reach out to me on Twitter, my blog that's currently in the works, LinkedIn, or email me directly. If anything, there's obviously, as I said, there is some metrics that I brought up earlier, but really, I don't want to just focus on numbers. It really depends on your projects. And if anything, community is not something you can really measure in numbers, in engagement minutes. You have to interact with them to know what's happening and how to fix it and how to make it better. Because it's all ultimately comes down to your community. All righty. I am hopeful that there is a way to do Q&A here. I am not sure if there is. I am hopeful. Let's see. Let me open my... But by the way, thank you for watching. It's always weird to give a conference talk like that. But thank you for sticking with me. Let's see. Let me actually go to YouTube and see if there are actual questions. Top chats. Chats. Okay. We hear you and see you. That is great. Thank you so much. Okay. What else do we have? Let me refresh. Okay. Are there any questions? Does anyone have any questions? Okay. Subscribers only mode. Subscribers who can leave it. Okay. Interesting. Okay, I'm not sure if there are going to be any questions, but if there are, again, feel free to ask me by directly messaging me, and I'll share my slides on my Twitter account. I am not sure if the conference get to share them too. If they want to, I will give it to them. But yeah, thank you so much for your time, and stay safe, everyone. And I'm lucky to see you all interested in open source. So again, thank you, and enjoy the rest of the conference. Thank you. This is the camera. Okay, goodbye. How do I? Okay.
Okay, so good morning, good afternoon, or good evening, depending on where you're tuning in from. And welcome to JavaScript and Friends. So my name is Håkan Silfvernagel, and I am working as a manager for AI and big data at the Norwegian consultancy company called Miles. And today I'm going to be talking about how we can run machine learning in the browser using TensorFlow.js. But before we start with all of this, I'm just gonna take the chance here and say a couple of words here about myself. So my background is in human-machine interfaces for process automation and robotics. And I am also quite involved here in the local user community. So I'm part of the organizing committee for the Norwegian.net user group, and also for Oslo AI, and also for the Azure user group Sweden. And I'm also together with Eve Pardy, another Microsoft AI MVP. We are organizing an online AI school called AI42. I'm also a Microsoft MVP in AI and also a Microsoft certified trainer. And if you want to reach me, you can see my social media links on this slide. And I'm just gonna try to rearrange my windows here. One moment here. Good. So the agenda here for today is first, I'm going to be giving everyone a background here in machine learning. And after that, we will dive more into TensorFlow and specifically into TensorFlow.js. And then we will also have two demonstrations. We will build an application from scratch, just using JavaScript, and we will load some data into our JavaScript application, and we will train machine learning algorithm so that they will be able to do a prediction based on new data that it hasn't seen before. And then in our second demo, we will use an off-the-shelf machine learning model, and we will build an image classifier. And actually, I have to just check here because right now it looks like something happened on the YouTube channel. Just one moment here. I'm not quite sure here if we are still live. Maybe the host can verify that. One short moment there. Okay, so then I think I will just continue here. Yeah, so we'll have these two demos, and yeah, so let me just start off here with the basic of machine learning. So what is machine learning? Well, you can say that machine learning is a field of study that gives the computers the ability to learn without being explicitly programmed. And maybe you think that machine learning has to be something quite new because it's such a hot topic today, but the matter of the fact is that it stems all the way back to the 1950s. And you can also say that machine learning is a type of pattern recognition in historical data. So some practical applications here of machine learning is prediction. So a classical example is if you have a house and you want to be able to predict the price of the house based on its location, based on the neighborhood, based on the number of rooms, and so on. So you can use machine learning for that. And another example is recommendation system. So probably if you've experienced that when you bought something in a web shop, the web shop will recommend some other items that people who are similar to you have bought. And you can also think about clustering. So that's a way of how you can send much more personalized information to a specific group of customers. So you can cluster these groups based on, for example, age or occupation or geography, or basically anything that you want to cluster. And you can also use machine learning for do image recognition, text recognition, and speech recognition. And one way that we can do machine learning is called supervised learning. So with supervised learning, we have access to historical input data, and we also have access to historical output data. And based on this historical data, we will be able to build a machine learning model so that we can train this model so that when it sees new data, it can take this data and then it can give us back a prediction or a recommendation. So as I said here before, machine learning stems all the way back to the 1950s. So maybe you are thinking, why is it such a hot topic today? So the reason for that is that we have a number of enabling technologies for machine learning. So one of them is sensor technology, so that we can get a lot of data, sensor data, and we also have access to big data solutions so that we can do transformation and loading of data in the cloud. And we also have access to machine learning algorithms that we also can run in the cloud. And luckily for us as developers, we also have API and services that we can use so that we can use all of these in our own applications. And for completeness sake, I should mention that you can actually run machine learning in any type of language. But the thing is that you don't really want to start out from scratch. Instead, you would like to have language which has a rich toolbox with many types of libraries that you can use, so you don't have to program everything from scratch. So historically, there has been two languages which are very popular with machine learning. So one of them is Python, which has traditionally been more popular among people with a computer science background, and the other language is R, which has been more popular for people coming from a statistical background or from academia. So now when we know a little bit more about machine learning, then we can go into TensorFlow. So TensorFlow is an open source library that was developed by the Google Brain team, and it expresses its algorithms using something called tensor operations. And one big benefit with TensorFlow is that it supports distributed computing. So that is very beneficial if you want to use neural networks or deep learning. But what is a tensor? So tensor is something that we've taken from the world of mathematics. So in mathematics, you can distinguish between either a scalar number, which is a single real-time number, or a vector, which is a collection of numbers, or a matrix, which is like a two-dimensional collection of numbers. And then a tensor is just a container where you can store either scalars or vector or matrices. So that's the way that our TensorFlow library uses in order to store its data. It uses the tensor as its storage format. And if you have a Python program, then what you can do is you can import the TensorFlow library, and then you can start up a new session, a TensorFlow session. And then you can define some numbers here. So we can define A as a constant with a value of 10 and B as a constant with a value of 32. And then you can do some sort of mathematical operations. So in this example here, we just do an addition and then we run this operation and we just print out the result out on the console. So now we're going through a little bit about what the tensor is and what the basic TensorFlow library is. Then we can go into TensorFlow.js. So TensorFlow.js is a JavaScript library so that you can both train and deploy your machine learning models in the browser and also on Node.js. So with that said, we will start our first demo. But I'm just going to try one thing here to see if I can see the YouTube chat so that I can follow along if there are some questions. Right now, it doesn't seem to be any questions here. So let me switch over to the browser. Or actually, let me switch over to Visual Studio Code here. So in Visual Studio Code, what we have right now is we just have an index.html file. And in this HTML file, we have loaded the TensorFlow minimized version and also the TensorFlow.js visualization, the minimized version of that. And I'm going to describe a little bit later on what this is. We will see this in this demo. And then we also have a reference to script.js file. So it's in this script.js file that we'll write our application. So if we have a look at the script.js file right now, you can see that right now it's only printing out hello TensorFlow on the console. And if we switch over to our browser, we can run this file here, and then we can just see that it prints out hello TensorFlow. So now what we need to find is we need to get some sort of data, and then we need to do some basic analysis of this data and see if we can find any types of relationships in the data so that we can train a machine learning model so that it can try to predict one type of data based on another type of data here. So luckily for us, we have some data here about cars in the JSON file. It's going to take some water here. So in this JSON file, we can see some information here about the data. So we can see, for example, the miles per gallon, the number of cylinders, the horsepower, and the year it was manufactured, and so on. So what we would like to do is we would like to take this data from the JSON file. We would like to load it into our JavaScript application. And then after that, we would like to see if can we make a machine learning algorithm so that we can predict a new miles per gallon if we get a horsepower value. So in order for us to do that, the first thing that we need to do is we need to load this data into our JavaScript application. So then we will add some code here to our script.js file. So let me switch over to Visual Studio Code. This, and then here we define a function get data. So what we do is we do a fetch on the JSON file, and then after that we clean up the JSON file because we're only interested in the miles per gallon and the horsepower. So we filter out this data and then we clean it up. We remove the null values because we don't want to have any null values. And then after that we return the cleaned data. And then the next thing that we want to do here is we want to be able to plot this data to see if there seems to be any sort of relationship between miles per gallon and the horsepower. And we also need to define a run function so that we actually can run our functions here. So in this run function, what we do here is first thing we do is we get data. So we load our data from the JSON file, and then after that we map out so that we get on the x axis, we get the horsepower, and on the y-axis, we get the miles per gallon. And then after that, we're using a pre-built functionality from this TensorFlow visualization component. So by using that, we can easily render a scatter plot. So we render a scatter plot of the horsepower and the miles per gallon. And then we will add more code to this function as this example evolves. And we also add an event listener. So we listen to when the DOM content is loaded, and then we run this run function. So let's save this, and then we switch over back to our browser, and we just run this file here. So now we can see here that without us doing almost nothing here, we got a very nice scatter plot here because we use this TensorFlow visualization component. And then we can also see, so here on the y-axis, we have the miles per gallon, and then on the x-axis, we have the horsepower. So what we would like to see is, does it seem to be some sort of relationship between the miles per gallon and the horsepower? And if there is a relationship, can we build a machine learning model so that we can take some new horsepower data that the algorithm has never seen, and then it will be able to predict the miles per gallon. So luckily for us, if we study this scatter plot, we can see that there seems to be some sort of relationship here in the data. And that's a good thing for us, because then that's a good use case for a machine learning model. So on the other hand, if all of our data points would have been scattered all around the plot, that would have meant that there is no relationship for a machine learning model to learn. So that would have been a bad case. Then we wouldn't have been able to use machine learning. It wouldn't have made any sense. So now what we would like to do here is we would like to train machine learning model where the input is horsepower, and then the prediction is the miles per gallon. And so what we'll do here is we'll use these values that we have over here, and then we'll feed them into a neural network. And this neural network will learn from these example data so that it can predict the miles per gallon from a new horsepower data that it has never seen before. And this is an example of supervised learning that we were looking at in the PowerPoint presentation before. So the first thing that we do here when we have a machine learning problem is that we need to define something called the model architecture. And that is basically what type of algorithm should our machine learning model use in order to be able to compute its answers. So machine learning models are basically an algorithm that will take an input and then it will produce an output. And in this case, we'll use a neural network. So here the algorithm will be a layer of neurons with different types of weights that will decide what the output will be. And what we'll do is we will train this machine learning model, and during the training process, the algorithm will learn the best values for these weights. So let us add a function here that we call create model. Let's switch back to the code. What we do here is the first thing that we do is we define a model by using the TensorFlow sequential. And this is one of the most simple models that we have in the TensorFlow.js library. And it's called sequential because its input flows straight down to its output. But there are also much more complex models in TensorFlows, so that you can both have multiple input, multiple output, and you can also have branches in your model. And then after that, we call model add in order to add an input layer to our model. And this is connected to something that we call a dense layer. So a dense layer is a type of layer that multiplies the input with the matrix that we call weights, and then it adds a number that we call the bias to the result. So since this is the first layer of our network, we also need to specify the input shape, which in this case is 1. And this means that we have one number as an input, and that's the horsepower of the car. And then we need to set units. So the units is how big will our weight matrix be in this layer. And here we set it also to 1, so that means that there will be one weight for each of the input features of the data. And then we create our output layer. And in the output layer, we set units to 1 because we also want to have one number as an output, and that's the miles per gallon. So next thing that we want to do is we want to create an instance of this model. So we go back to our run function and then we create the model here. So we call the create model function, and then after that we're using this TensorFlow visualization component in order to show something which is called a model summary. So we'll have a look at what this model summary is right now. So let us run this again. And then again, we get our scatter plot, and then below that we have our model summary. So if you're used to running machine learning with Python and the Jupyter notebooks, then you're very familiar with this model summary. So what is the model summary tells you how many layers you have and what is the output shape, the data from each layer, how many trainable parameters you have, and so on. So that's sort of a standard functionality in the Jupyter notebook world, and now we can also have the same functionality here in the browser through this TensorFlow visualization component. So now when we have created our model, then we want to prepare the data so that we can train our model. So the first thing that we need to do is to convert our data into tensors. Because remember, I was saying that TensorFlow is only using tensor as a data format. So right now we have the data in the JSON format, and then we need to somehow convert it into the tensor format. And when we do that, we will also do some best practice from machine learning. So we'll do two things. One is called shuffling of data, and the other thing is called normalization of data. If we go back here and then we add a new function. So here we have a new function converted to tensor data. So what we do here is first we do a shuffle of the data. And the reason why we do this shuffle is because when we do our training, we will divide the data into subsets, into batches. And when we train, we want the batches to be as representative as possible of the whole data set. And therefore, we would like to have data from all across the data distribution. And this has some advantages. So one of the advantages is that you don't run into the risk of only learning things that are dependent on the order of the input data. And the second advantage is that you're not so sensitive to structures in subgroups. So for example, you could imagine that maybe for one reason you have high horsepower for the first half of the training data, and this would not be a relationship that would be representative for the whole data set. But now when we do this shuffling, we avoid all of that. And then we're using a pre-built function called tf.tensor2d in order to convert to tensors. So we call the input, which is the horsepower, we call that for input tensor, and then we call the output, which is the miles per gallon, we call that labels. And then we do a normalization of the data. So we calculate we find the max input, the mean input, the max output, and the mean output. And then we can do a normalization of the data so that we get all of the data into the range between 0 and 1. And this is called using something called mean max scaling. And normalizing is important because many of these machine learning models, the internal of the models, they're designed to work with numbers that are not so big. So if we do normalization, we avoid all of these kind of problems. And then finally, after we have our normalized data, we return the input and the labels, and we also return this mean and max bound. Because the thing is that after we've done our machine learning training and we get some new data as predictions, then we need to have some way in order to scale it back to the original scale. So that's why we are also returning this input max and input mean and so on, so that we can convert our data into the original scale. So the next thing that we would like to do is we would like to train our data. or train our model here. So then we add a new function here called train model. Let me add that. So here in our train model function, what we do here is first we need to prepare our model for training. So first thing that we need to do is we need to compile our model before we train it. And we also need to set some parameters for this compilation. So one of the parameters is the optimizer. So the optimizer is an algorithm that will decide how the updates of the model will be. So there are many types of optimizers in TensorFlow.js, and here we've picked the Adam optimizer because it's quite effective in practice and it requires very little configuration. And then we also need to define a loss function. So the loss function is a function that will, like a quality function, that will tell us how well is our model doing when it tries to learn on each of these batches or data subsets. And here we use something called the mean squared error to compare the predictions made by our model with actual true values. And then finally, we need to pick a batch size and the number of epochs. So the batch size is referring to the size of these data subsets that the model will see. So some common batch sizes can be in the range between 32 and 512. And there isn't really any ideal batch size that will solve all problems. And it's also sort of a science in itself to choose the batch size. So here we've just taken a standard batch size of 32. And then epochs refers to the number of times that our model will look at the entire data set. So in this case, we have chosen 50. So that means that our model will take 50 iterations with the data set. And then finally, we start our training loop here by calling model fit. And then we input our inputs and our labels and these parameters, the batch size and the epochs and so on. And then we can also define a callback function so that for each epoch, we can call this callback function and we can monitor how well this training is going. So we can model the training performance and we can print out the loss function and the mean squared error. So then it's time to actually do some training here. So then we need to add some code here to our run function. So here we do first a conversion of our data to tensors, and then after that we extract the inputs, the labels, and then we call our train model to do the training of data. And then we will print out on the console log done training when we're actually done training. So we'll run this for 50 epochs. So then if we switch over to the browser, and then we run this in our browser, then we can see, so here we can see the monitoring of our loss function and the mean squared error here for each epoch. So the epoch is on the x-axis. So right now it's around 26, and then it will go until 50 because we selected 50 as the number of epochs. And we would like to have this as low as possible. So now we can see that it's reached 50, and we can also see in the console that we have the done training is printed out. And then if you look here, now you can see that the loss function is somewhere 0.02 after 50 epochs. So let's say that we are happy now with our training. Then the next thing that we want to do is to actually do some predictions. So we want to generate some new data, some new horsepower data, and then see how can we predict the miles per gallon from some new horsepower that our model hasn't seen before. So let's add a new function here that we call test model. Let me add this. And let me go back to the code. Yeah. Let's say what we do here in this function here. The first thing that we do is we generate 100 new data here and 100 new X values that we will give back into our model. And then we just call model.predict with this new X values that it has never seen, with this new horsepower values. And then we get back our predictions. And then, as I said before, we need to do an normalization of our data so that we can get it back to the original scale. So we are using this input max and input mean and label max and label mean in order to scale our data back to the original scale. And then we just, finally, what we do here is we render a new scatter plot where we can plot our model predictions versus the original data. So then we can see how well our machine learning model is performing. We save this, and then the only thing that we need to do now is we need to call this function from our run function. We switch back to the browser and we run this. And then I should also mention, because right now we are doing the training all of the time when we run this this example, but that's just because this is just an example. So in a real use case, you don't need to retrain your machine learning model every time you run it. But what you should do is you should monitor your machine learning model so that you can see if it deviates too much. Then you should do some retraining. But finally, we can see here. So the blue things here is our original data, and then this orange line here is our prediction. You can see that it doesn't seem to have predicted so well. And the reason for that is because if you look here at our blue data, it looks like there is some sort of curve, some nonlinear aspect in our data. And right now what we try to do is we try to predict using a straight line. And that doesn't work very well for us. So maybe we actually should try to create a different type of machine learning model that takes into account this nonlinearity aspects of our data. And if we do that, maybe we can get some better performance here from our machine learning model. So let us go back to where we defined the machine learning model, which is somewhere over here. Then we comment this thing out. And now we create a new model here with some more layers here. And we also have an activation function, which is called a relo function. And I'm not going to say so much about it, but what it actually does, it's that it enables the machine learning model to take this non-linearity into account. So hopefully this model will perform much better than our previous one. So if we save this and then we go back to our browser, then we run this, then now we can see here in the model summary, we can see that we have many more layers. We can also see that we have many more trainable parameters. So for a second layer, we have 128 trainable parameters, for a third, 4,160, and so on. And that's a good thing, because then it will be able to take into account this non-linearity of our model. And we can also see here from our training performance that it reaches a value here, 0.015, which is much lower than what we had in our previous example. We can also see that it reaches it after just 10 epochs, which is also better than what we had in our previous one. And then finally, we can have a look at this plot of our model predictions and our original data. And then we can see that this new machine learning model performs much better than our previous one. So you can see that now we're taking this non-linearity into account here. So you can see that this orange thing here have a slight curvature, like the blue data here. So that concludes our first demo. So what I would like you to take away from this demo is that now, by just using JavaScript and using this TensorFlow and the TensorFlow visualization component, we can both do some data analysis, and we can also do set up, construct a machine learning model, and we can train a machine learning model, and then we can also test it with some new data and do some plotting out of that. So that's pretty powerful to do just right here in the browser. Let me switch back here to our presentation. So, but one other thing that you can do is you can also import an already existing model into TensorFlow.js. So, for example, so what we're going to do here is we're going to import something called a MobileNet model, which is a Keras model in the H5 format, and then we will be able to convert that to TensorFlow.js layers format by using a utility that you can run either on the command line or you can run it from Python. So if you use it from Python, then what you do is you import Keras, you import TensorFlow.js, and you import TensorFlow. And then you load your MobileNet model, and then you just call this utility TensorFlow.js converters, and then you save your Keras model as a layers model. And then in your JavaScript application, you can import TensorFlow.js, and then you can just load this converted model by using a function called load layers model. And we're going to have a look at how that is done in our second demo in a short while. But before that, we can think it can be worthwhile to take a little bit of high level and think about why do we want to use TensorFlow.js from the start. So let me just take some water here. So one of the reasons that we might want to use this is because we don't need to learn another language. We don't need to learn about Python or R or notebooks and this stuff. And another thing is that we don't need to do any round trip within the client and the server. So in this example, all of this machine learning will take place on the client. And you can also argue that your user data will be more secure because all of the user data is local. And you will be able to use the browser application, which is both highly interactive and also easy to use. And you also have easy access to sensors, like the webcam and the microphone or the gyroscope. And you can take advantage of GPUs. And as I said, there are some different ways that you can use this. Either you can run existing models, so either you can use off-the-shelf models, or you can convert an existing Python TensorFlow model to run in the browser by using this utility that I was showing you before. And you can also retrain existing models. So let's say that you have a machine learning model that will be able to detect cars, then you can specialize it so that it's able to detect just the Tesla cars, for example. And then finally, what you can do is you can develop machine learning just as we did in our first demo from scratch and do the training and the testing in the browser. So here are some examples of some off-the-shelf models that we just can download and we can use straight off the shelf. So we have some models for image classification, for object detection, and so on. So we're going to be using one of these models, which is this ImageNet model, which is an image classifier, in order to build our own image classifier using JavaScript. So let me switch back here to, actually, let me switch first back. I can show you what it looks like. So this is the way that this JavaScript application would work. So first we select an image here, and then after that, we select the machine learning model. In this case, we'll select the MobileNet model. And then after that, we click on the predict, and then we can see that it predicts that this is a strawberry with 99.9%. The way that this was done is, let me switch over here to Visual Studio Code, so we can have a look at how this is done. So here in this first file here, this is just some HTML file to make up the user interface. So here are some options for selecting a machine learning model and select an image and so on. And here's the important thing here. So here we load in our TensorFlow TensorFlow.js library. And we also have something called ImageNet classes.js. I will tell you quite soon what that is. And then this is the really important file here, which is called predict.js. So it's in the predict.js that we do all of this machine learning stuff. So if we go to predict.js, then here when we select an image, we read the image into our application. And then when we select the model here, we call the load model function. And then the load model function is based here on our directory structure. So for example, when we selected our MobileNet model, then we will go into this directory structure here, TensorFlow.js models, MobileNet, and then we'll select this model.json. And the model.json is the result of using this utility that I was showing you in the PowerPoint slide. So what we've done here is we've taken the ImageNet, Keras ImageNet model, which is an H5 model, and then we've run this utility and we've converted it to a TensorFlow.js layers model so that we can use in our JavaScript application. So here we just need to do load layers model with our new layers model. And then when we click predict, what we do here is we need to do some pre-processing of our image, because remember that TensorFlow is only using tensor as its format. So we do some pre-processing of the image to get it in the right format. And then the only thing that we need to do is we just need to call model.predict in order to get our predictions. And then we just sort out the top 5 predictions and we print out what is the probability. And actually what we get from our model is the probability and then an index. So the index is an index into this ImageNet classes file. So the ImageNet classes file, so I have it there. This is just a mapping from an index over to a clear text of what it actually represents. So that's basically what we do. So based on this second demo here, what I want you to take away from this is that it's quite simple here to use some of these off-the-shelf models and build your own application from based on that, and that can save you a huge amount of time. So now let me switch back over here to our presentation. So, right. So now in the ending part here of my session, I'm going to give you some examples here from the real world, how companies have used TensorFlow.js in some real world applications. So my first example here is from Uber. So Uber has something called Uber Manifold, which is a visual debugging tool which uses TensorFlow.js. And if you want to know more about this, you can go to GitHub, where you can read all about this manifold project here. And another example is from Airbnb. Airbnb has something they called an identity document detection. So when you rent out your property on Airbnb, there is a risk that maybe you have left some sensitive information, like maybe your passport or your driver's license or something in the photo. So what Airbnb has done is they are running a machine learning model on the client in the browser. So if you're about to use a picture that contains sensitive information, it will alert you before you upload that picture. And then we also have an example here from the world of music, which is called Magenta. So Magenta is using machine learning models for music generation. And you can learn more about it on the magenta.tensorflow.org. And that concludes my presentation here. So I also have some references. If you want to know more about this, you can either watch the official documentation of TensorFlow, and there are also some courses on Coursera that I can highly recommend. And if you want to know more about this image classification example, there is a Deep Lizard video series on YouTube. And you can also study some of the code labs that are on google.com. So if you want to reach me, you can always reach me on Twitter by using my Twitter handle or grab list, or you can send me an email on this mail address. And you can also connect on our Slack channel, on the JavaScript and Friends Slack channel, and you can ask your questions regarding this in the Track5 questions, and I will answer your questions there. I can see that we have a couple of minutes left here, so I'm just going to go quickly give you some more information about this AI school that I was talking about. So together with Eve Party, which is another AI MVP, I'm running the AI 42 online AI school. So what we do here is we are streaming on YouTube and on Twitch and on Facebook every other Wednesday. And we are connecting with experts and recognized speakers that will instruct you on particular topics. So we started out with mathematics and statistics and probability, and then we go more into different types of languages like Python and R, and now we're looking into more of tools like Power BI or Databricks and so on. And we will also look into machine learning and deep learning. And the goal here is that we would like everyone to be able to get into this interesting world of data science and machine learning, and that we'll be able to go all the way from complete beginner so that you will be able to build your own model and deploy it. And you will be able to reach us either on Instagram, on Twitter, or on Facebook, and you can reach our YouTube channels to see our previous sessions, or you can register on our meetup page by scanning this QR code. So with that, I recommend that you connect to the JavaScript and Friends Slack channel and you ask your questions there, or you can reach me here on the Twitter channel. I'm going to do one last attempt here and see if I can get the YouTube channel up and see if there is some comments. Okay, some people are thanking for the presentation. Yep. So I hope you got some valuable information here from this. So with that said, I will just wish you a great continued JavaScript and Friends conference. So thank you so much.
Great. Hey there, everybody. Hope you've all been having a wonderful conference. I am so happy to be here today and share you a little bit of what I've been up to and what this project is all about. I'm pretty new to hardware, but I've been having a wonderful time with it. And my hope is to get you all excited about it and to try out a little bit of hardware stuff yourself. So if you want to follow along with my slides, I've got them in PDF form for you to download. Just go to the link you see at the bottom of my slides here. You can see my show notes. Sorry about that. Just go on down to ramonh.dev/dance-mat.js.pdf. Great. So let's get into it. Just a heads up, I'm going to be playing a little bit of the music from Dance Dance Revolution. So I'll be playing it through my speakers. It won't be terribly loud. If it is loud, please do give me a shout and I'll make sure it's at a better level. But it'll be great, I promise. So let's get into it. A little bit about me. Hi, my name is Ramón. My pronouns are he, him. I'm originally from Chile, but I've been living in Vienna in Austria for 20 years now, 21 years, quite a while. And so can't really call myself Chilean anymore. But so I've been developing software for the better part of 10 years. I'm currently head of open source at CodeC, a company that's building some tools to help people become more familiar and being able to onboard to complex code bases. I'm also a developer relations consultant. I've been programming a lot of my career in Ruby, in JavaScript, in a lot of native mobile, a lot of native macOS, a lot of web application development, and more lately doing some Rust, which is a lot of fun. And I like to put myself on my CV as a community member. I really, really enjoy and appreciate tech communities. I think if it weren't for them, I wouldn't be doing the things that I'm doing today. And I'm so grateful for them. And I think I owe the majority of what I've learned and the majority of my passion to these online communities. So I really want to give them a shout out, no matter where they are. It's been wonderful to be able to connect with people. And I've also been part of this Mozilla Tech Speakers program, now more of an informal group of people, and it's been just so joyous. In order to get myself there, I've also spent a lot of time teaching kids to code. I think teaching children has so much value because not only are you teaching them, but you're also learning a lot about how to think for yourself, how to process arguments, and how to verbalize concepts in a better way. And and I've also been a football coach for kids. That's European football, so soccer. So let's talk about music games. Let's talk about dancing games. A little bit old school. You might all be familiar with Let's Dance. Pretty fun game where you wave around the controllers and you dance to the rhythm. I never played it myself, but it looked a lot of fun. Maybe more recently, you might be familiar with a virtual reality or VR game called Beat Saber. Oh my God, the name escaped me for a second. Yeah, Beat Saber. I only played this once, but I instantly fell in love with it. What you've got is you've got your two VR controllers and you're waving them, and you've got these lightsabers and you're just cutting these cubes to the beat and like dodging walls and stuff. It's a ton of fun. But today I want to talk to you a little bit more about an older game from my childhood that some of you might have played. I don't know, put some emojis in the chat if you are familiar with Dance Dance Revolution, or as I'm going to refer to it moving forward, DDR. I loved this game as a kid. I still love it today. And what it is, as you can see in this very helpful GIF here, is you've got this controller on the floor made up of a series of buttons, an up, down, a left, and a right arrow. And you press these, you've got these arrows moving up on the screen. I'll show you a picture of it in a second. And you're pressing these buttons and it to the rhythm, and it kind of looks like you're dancing. It's so much fun. If you haven't tried it, see if you can get a copy, or maybe try it out on arcade if maybe your arcade still has it. There's a bunch of alternatives as well, and it's a ton of fun. The one that I grew up playing was DDR on the PlayStation. This is pretty old. This is like 1996, 7, 8, 9, something like that. And it was great. So what you see here, right, is you've got these arrows, right, that are moving upwards. And what you do is you as they hit the shadowed arrows at the top of the screen, that's when you're meant to press the button with your foot and just like, go for it. Sometimes you've got 2 arrows at the bottom here. You can see there's 2 arrows at the same time. And so you press both at the same time, and it kind of looks like you're doing these little jumps. It's so much fun. And the music, the music was a blast. Do you know what? I've actually got a sample here. I'm going to play you a little bit, just a couple seconds, just to give you an idea of what was going on. This is some like late 90s techno Europop stuff. And it's just like, anyway, I'm here to give a talk. It was a lot of fun. I really loved this game. And so I want to say about four-ish years ago, I introduced the game to my wife and she loved it. She was like, oh, this is so much fun. Let's get it at home so that we can play it. And getting a copy of the original PlayStation game or getting a newer copy, even at the time, was kind of tricky, and getting the controllers as well. But as it turns out, thanks to some wonderful developers out there, there is an open source version of DDR called Stepmania. If you're familiar with it, it's wonderful. Actually, funny story. I gave this talk in JavaScript Bangkok 100, and one of the organizers used to be a maintainer of Stepmania. So when he came up to me later, he's like, oh, yeah, Stepmania. So nice that somebody's giving a shout out to it. I used to develop it. I was like, what? Anyway, and it's great because it allows you, sorry, my landlord took out my windows and it's a little loud. Sorry. Yeah, and it's essentially the same as DDR, as what you see here is actually a 2-player screen, because yes, you can have 2 players side by side. The arrows are moving up. Some people are actually so pro that they use 2 of the dance mats and they play across both mats. It's a ton of fun. Yeah, so what you see here, right, is that arrows are moving up. You can download any kind of music you want, and it's a ton of fun. I highly recommend it. And so what we had to do, because of course we couldn't play at the arcade, we had our own machine. And so we were playing this on a computer, and we were lucky at the time, there were still available these dance mat pads, right? Which these were made of foam on the inside, and they had these contacts that you could press to do the button presses. This one has a PlayStation controller port on it, but you also had like USB ones that you could plug into a computer, and it was great. So yeah, you could plug this into your computer and you could play DDR, you could play Stepmania on it. Now, the problem with that was, sorry, just gonna move my microphone a little bit. The problem with that was that after a lot of use, we used it a lot. So after a lot of use, like several months, maybe even years of use, the contacts on these pads would start to wear out with time. Right. So what would happen is that after a while, they would start to fail, or you had to press them really hard, or sometimes it would recognize it. Sometimes it would happen that you would press it and then it would just stay pressed because it thought it was still being pressed. And it was quite tough. And we weren't experts in trying to diagnose the problem. So a lot of the time we ended up seeing this screen here, the game over screen, which was quite sad, of course. So we thought, hey, they do sell these mats like in the arcade, and in the arcade, you've got physical, big metallic buttons that could, you could really give it a good stomping. And that was great. And you could buy these for home as well. Now, the problem was, foam is a lot less expensive than metal. So usually, here's a screenshot from an online store. You could get these for about $339.99. And that's a steep asking price, but I don't know if you can see, but that's actually it's actually on sale. It's a sales price. And if you look up, it's $919. That's almost $1,000. That's a lot of bones. We couldn't quite afford it at the time. So we kind of let it be. We used our broken mats and just went on with our lives and did our dancing. And a few months later, there's this event. I don't know if they have it in your area. Unfortunately, due to the global pandemic, I haven't seen it last year, of course, and this year either. But there's this thing called the Maker Faire. I don't know if you've been there. It's super fun. And what this is just like, I'm sorry, it's in German, but essentially the screenshot's in German, but essentially what it is just an event where people can come and set up booths for their techie nerdy stuff, or have like workshops or all kinds of stuff. And it's a lot of fun. And so we went there one year, and we were introduced to a company called Bear Conductive. If you're not familiar with it, they sell this stuff here. They sell what's called conductive paint. Now, what you see here is a piano made of conductive paint. Now, I used to see these on YouTube. Like they had these, what this paint does is the name suggests, it conducts electricity, right? So I saw these YouTube videos where they like painted a circuit out of paint, from a battery to a light bulb back to the battery, and that would create a circuit, and the battery and the light would illuminate. And that was super cool. And I thought, oh, that's pretty neat. But when I was introduced to them here, as you can see on this photo here, it's also capacitative, which means that it also creates a charge when you touch it, right? So what this piano does here is that you touch one of the keys, and a little MIDI tune would come out of the speaker that you see in this photo. So I took a look at this and I thought, that's cool. Anyway, so I went home and I looked this up. Maker Faire went on for a couple of days, so I had some time to think about it. And I went home and I took a look at their open source stuff. Now, what you see here is a screenshot from GitHub. And what you see here is a Node.js framework they've made for it that interacts with the Raspberry Pi, a piece of technology that's about the size, smaller than a credit card actually, that is essentially a Linux computer. More on that later. But yeah, this is a Node.js piece of code that I could copy paste and start messing around with. And that had me thinking, I could make something with this. I love this GIF. Anyway, so we took a look at this. So taking all this into account, and also taking into account the fact that we have in StepMania, this is a screenshot from StepMania, we can take the controls and remap them to whatever I like say my own keys. So I thought, hey, why don't we take a yoga mat, a Raspberry Pi, the Pi cap to interact with the paint, some of the paint, and a little bit of Node.js, and make our own dance mat. That would be super cool. Now, a little bit to elaborate on the Raspberry Pi, it's this device you see here. What it is a tiny computer that has Linux on it, and the pins to allow you to interact with it, do some hardware hacking. This one has built-in wireless LAN and Bluetooth. So, well, from all that, we were able to onboard it and make our own dance mat project. And that's what you see here. This is a screenshot of GitHub of my very own dance mat project. And well, we thought, hey, let's get going with it. Let's make some hardware. Let's make our own dance mat. Now, the thing is, this was my first ever hardware project. So I wasn't all too sure what I was doing. I was very eager to learn, but not really knowing what I'm doing. So let's take stock. Let's think, okay, what is it that I want to do with this Raspberry Pi? What I want to do is take my dance mat, which is, remember, a yoga mat with the paint on it, and connect that to the Raspberry Pi, right, via the paint, and connect that Raspberry Pi to the computer. And the computer would say, this is a keyboard. Great. Let's treat it as a keyboard. Now, the code was a Node.js script that would run on my Raspberry Pi, that every time, what you see here is the sample code from the Bear Conductive framework. And so what it would do is it would interact with my Pi, and every time I would press one of the diodes that you see along the cap, more on that in a second, it would just send the data to the PC. And you see there, I left myself a nice big comment in all caps, send data to PC. And this is where the big question was going to come from, because I thought, okay, well, if I want to connect it, I don't necessarily, given that this thing has Bluetooth, why not just connect it via Bluetooth and send the keystrokes via Bluetooth? Well, turns out Bluetooth is pretty involved. And again, I'm not an expert on this stuff. I'm just a web developer. So turns out it's pretty involved and pretty laggy as well, as you can see here in my expertly drawn squiggly arrow. Yeah, it's not that easy to get that going. So I thought, okay, let's forget Bluetooth. Let's keep it simple and communicate directly via USB, right? Turns out that the Raspberry Pi, as you can see in this picture, has 2 ports, right? One for USB communication and one for power. So I thought, great, we'll just connect that USB port to the computer and have the computer think that's a keyboard. So if you're not familiar with doing lots of hardware stuff, it's not that you can just plug a Raspberry Pi device into a computer and the computer is like, aha, this is a keyboard. No, it turns out it's not. It turns out it's not that simple. So you might be thinking, Ramón, did you not think this through? Like, did you not know this? Did you do any research? Just let me remind you, this is my first ever hardware project. I'm learning as I'm going. So I did some research and I learned that the Raspberry Pi, amongst a whole other bunch of devices, can be used to be called to be recognized by a computer as what's known as a Linux USB gadget, right? And the Raspberry Pi OS, Raspbian, I think it's now called Raspberry Pi OS. Back at the time, it was called Raspbian, a derivative of Debian Linux. I think it still is, it's just called differently. Anyway, what you can do is with config.fs, mount it at boot when the Raspberry Pi starts up to tell the computer, hey, I am a USB keyboard. Don't worry about what I do. I'm a USB keyboard. And I found not only this great documentation you see here at the top, I actually found a tutorial that I'm extremely grateful for. This link here will take you to an excellent tutorial to do exactly what it is that I needed to do, which is to configure my Raspberry Pi to tell the computer, hey, I'm a USB keyboard, right? So this involves 2 steps. I'm going to summarize what the blog post here does. Definitely recommend checking it out, though, if you're interested in this sort of thing. We need to do 2 steps here. First of all, we need to enable the Raspberry Pi in what's called the USB on the go mode, right? This is where, in order to save myself some cables, when I plug the Raspberry Pi into the computer via this USB port that I showed you before, it will instantaneously recognize that as a keyboard and, no, sorry, not instantaneously recognize, sorry, give it power via USB, right? Step 2 is going to be adding this script on config.fs, which is the config file system that will enable the keyboard HID, which if I remember is human interface human interface device. I just did an ATM machine. Anyway, this human interface device on the config.fs, right? So plug that in, and so with that I can mount the operating system on my Raspberry Pi, connect to it via SSH, or plug it into a TV and interact with it via the terminal, and just say, run these 3 scripts here. What these will do is enable that on-the-go mode, right? These will enable these file system extensions that will allow the Raspberry Pi to say, hey, power me on via USB. It's no problem. Yeah. So that's step 1 done. We've enabled Raspberry Pi on the go. The second one is to add this script. Now, that blog post that I linked you to before actually provides this bash script, and it is big. Let me tell you, I have to be honest with y'all. I just copy pasted most of it. No, pretty much. What am I saying? Most of it, all of it, right? And what this does is it creates this interface with the computer so that I can interact with it via USB and tell the computer, hey, I'm a keyboard, right? Now, the most important part you might notice that I'm pointing out here with this lovely green arrow is the 3 parts. See, what this happens, what these 3 do, I don't know if, like, when you've plugged in a device into a Windows computer, at least, you know how it says like installing this device by this manufacturer? This is what this is here. So I gave it a serial number, I gave it a manufacturer, who is me, and give the product name, in this case, the DDR dance-mat, right? So I'm learning a whole bunch here, like config.fs, right? As I said before, it's this virtual file system mounted on the Raspberry Pi for doing kernel level configuration so that you can do things like treat it as a USB keyboard. And it turns out that Raspbian, again, Raspberry Pi OS now, comes with so many options that allow you to configure it. And the documentation is stellar. I highly recommend checking it out. At this point, I was already like super satisfied with what I was doing. I was learning so much. I felt like I know my hardware now. But it turns out that just telling it it's a keyboard doesn't really do everything, because you still got to actually interact with the computer as a keyboard. And that's where the next step comes, right? So what you see here is the documentation for the USB human interface devices. I was right. I did do an ATM machine. Right. So what this is the documentation from the USB standard for the how to interact with a device as a USB keyboard or human interface device would. And it comes with a PDF that you can download that if I remember correctly, was like, I can't remember if it was 40 or 400 megabytes. It was a big document it had hundreds of pages. I remember reading that and making that sound, like when I saw how many pages, you know, that sound that a dog, like a big dog, like a basset hound makes when it barks, it goes like something like, woof. It was a meaty document. So I had a lot to learn there, but it's okay. I read through a little bit. I also talked to some friends about it and sort of tried to get a better understanding of how this stuff works. And it was a nice reminder that when it comes to this sort of thing, you know, just as much joy as I get from helping others out, reaching out, there are excellent resources out there. There are excellent communities out there. There are excellent people out there who would be delighted to show you the ropes a little bit, or at least learn alongside with you. And by the way, that goes both ways. So if you know a lot about this stuff, I highly encourage you to seek out communities where people are learning this stuff. And, you know, if you have the time, of course, and provide them with that learning, because it goes so far. And well, I could talk about mentorship for ages. That's another talk. So what I learned, right, in order for a USB device to interact with a computer as a keyboard, what it boils down to is a keystroke, right? Every time you press a key or a couple of keys, that's a keystroke. Like, you know, like a piano, you go like bling. I'm looking at that keyboard. I can't do a piano sound. I'm sorry. Yeah, so what you've got is this keystroke. And what it is a series of hexadecimal keys. So it's an array, a byte array, right? With each of them representing one key, right? Except for the first two. The first two members of this array are what's called control keys. And as the name might imply, this could be things like Shift, Control, Alt, Super, Windows key, Command, you know. So we've got this array, and what I would need to do is that for each button that I press on my dance mat, I need to create this byte array and send it to the computer, right? So first steps first, what I found was a list of the hexadecimal keys that correspond to each letter or each ASCII character on the keyboard. So we've got, for example, what do you see here? A is hexadecimal 4, B is hexadecimal 5, C is hexadecimal 6, and so on and so forth. So I just took those and I just put them in my script. I defined player 1 left. Oh yeah, this can be more than 2 players. I've got a lot of diodes on this thing. You'll see it in a second, right? Yeah, so player 1 left, player 1 right, player 1 up, and player 1 down are going to be A, B, C, and D respectively. I put those in. I was already feeling like, yeah, I got this. I know what I'm doing. I'm learning. Right? So great. I've got these defined. Now comes the part where this script, you might remember, you know, where I had that big comment that said like, send data to PC. Right. What it does is it receives an array of pressed diodes. See, this thing has a bunch of diodes that I can connect to my dance mat. And from that, I can grab the data and send that to the PC. So the first thing I did was I would just grab that data and turn it into a series of keys. This is this function here, parse pressed keys and pass with the data that comes from the diodes on the Raspberry Pi. And that's where this cap comes in. See this photo here at the bottom right? This is the cap that goes onto the Raspberry Pi that lets it interact with the dance mat. And you see it's got a bunch of diodes at the top. It's got 12 in total from E0 to E11. So what I would do is essentially just loop through each of those diodes, sorry, not diodes, electrodes, each of those electrons, I'd loop through each one of them, and depending on which one it is, that would correspond to a key. So if it's 0, then I will pass to that array the player 1 left button. If it's 1, then I press right. If it's 2, I press up, and if it's 3, I press down. And I would just return this bunch of keys that I press. And remember, this is on each tick. So if there's keys pressed, it will pass them over. Perfect. Now, the next step is to take those keys and just make sure that we've got that keystroke, that array of 8 hexadecimal values, right? Because what could happen? I could have only one pressed, I could have none pressed, but I still need to send a keystroke. If no keys are pressed, then I send 8 zeros in. I still need to build that and make sure it's there. So I will build that keystroke. I will take those keys, prepend to that array the first 2 control bits. Remember I said that we've got those 2 control bytes at the beginning, and then just push our keys, and just to be a little bit lazy, just make sure that there's 8. So I would just chop off any that were left over, because remember, I've got 12 here. And maybe you might have noticed this in some operating systems or some keyboards. Especially if you're my age and you were playing games with your friends on one keyboard, sometimes you couldn't press more than either 3 or 4 keys. I think it's because of this. From what I understand, it's because of this human interface device. Although that was serial back in the day. Anyway, yeah, so I would just print that out in the console. I would start up the app. I would start up the script on my Raspberry Pi and just touch the electrodes and make sure that it was building these keystrokes. And indeed it was. But remember, I said this is a bytes array, not an array of hexadecimal symbols. So I need to turn that array of keys into a byte array. And I cannot sing the praises enough of communities like the Mozilla Developer Network web docs, because there's actually a function in JavaScript that allows you to do this called uint8 array. And what this does is you give it an array, and it'll turn that into, by calling uint array from, and then you give it your array, it will return to you a byte array. So I was able to turn that into a buffer of a byte array, and build it out of my keystroke. Almost done. Now comes the fun part. Now comes the part where we send the keystroke. How do we do that? It's not just as simple as being like, well, keystroke.send. No, we actually have to interact with our Linux, with our config.fs. Remember, we set up that interface in Linux that allows us to interact with the computer. And if you're not familiar with Linux, from remembering my uni courses, like they always said, like, oh, everything in Linux and Unix is a file. And in this case, it applies, because what we did was create a file interface that I could write to, so that the Raspberry Pi would tell the computer, hey, I've got some data for you, right? And so we could do that. And that's how most of Linux things operate. This is called a file descriptor. And it turns out that it's used pretty much universally in Linux and Unix. A file represents a whole bunch of stuff. It can represent devices. It could represent addresses, like other devices around you, and of course represent things like documents. So it turns out that by running this script on boot to tell the Raspberry Pi, hey, you are a keyboard, tell the computer you're a keyboard, what it does is it creates a file that I can interact with, right? I can pipe data to this file, HID, the human interface device. I don't know what G is. It did that automatically. I might have had to read that code. Yeah, and what it does is it'll allow me to write data to this file, and it'll tell the computer, hey, I've got data. Here's the data, right? So really, I could just, it's as simple as piping data to that file, like writing data to that file, like blah, 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 I am a keystroke. Of course, that's not going to work. It's not going to be a proper keystroke, but I am essentially sending that data. Now, when looking into how to do this in a nice way in Node.js in Raspberry Pi, I thought, you know what'll be easiest if I just see if there's a package maybe that somebody wrote. And I cannot sing the praises enough of open source communities, because believe it or not, there is an NPM package that does this. What you see here is a screenshot of the Linux device package. in NPM that allows me to interact with Linux devices. And what it does is you of course import it into your script. You open up that device. You see there the dev hit G0, 16-bit byte arrays. And all you have to do after that is, as you see here, my completed function here is just write to that device. And of course, when you've got an open device like this, you got to be a good citizen. When you quit the program, you got to close that device so that it doesn't get messy. Yeah, so with all of that done, the way to test it is to run the node file, run node dance-mat.js. And since this is keystrokes that I'm sending, all I really got to do is, open up a text editor and start mashing away at it and see if it writes keys. And folks, you're not going to believe this. It worked. Look at that. Look at those A, B, C, and Ds. It worked. It was astonishing. I was so excited. Well, having all of that done, the next step was to start painting. This is like one of the most fun parts there was. So what you see here is an actual photo from our apartment of us of us painting the dance mat. Take our yoga mat and start painting it. It was great. It was a big enough yoga mat. We could paint two of them. So we had two players. We did realize, by the way, as you can see, they're pretty close together. It turns out that having two people dancing that close together can get a little bit dangerous. So actually we had to cut it in half. So what you see here is one of the halves. So this is like player one, right? And what you see here, we're painting this with the conductive paint, right? How cool is this? Like we could design our own buttons. It was wild. And so we did it. We wired it up to the Raspberry Pi. Did it work? Yes. Were we good at it? Were we good dancers? And kinda, we were getting Ds, but hey, better than game over. So we were all set. We had our dance mat. We could play. It was great. Now you might be wondering, are we set for life? It kind of depends how you look at it. So I'm going to do a little bit of computer. Please zoom in. See, the thing about this mat, thank you, computer. What you see here is, it turns out if you put paint on a flexible yoga mat, after some time, that paint is going to start to crack. It's going to start to wear off, right? So there were a couple of caveats to our project. So we started building a list, my wife and I, of things we would do if we could do it all over again. For example, I went to one of my friends and I was telling them about this project way after, and they're like, "Oh, Ramon, that's really cool. You should have used an Arduino." To which I replied, "Cool, great answer. Quick question. What's an Arduino?" Turns out it's a microcontroller that you can interact with, and it's a lot more lightweight than putting in a whole Linux computer just to be a keyboard. Well, lesson learned. We could have used a smoother surface, maybe use some lacquer, I don't know what the word is, but this material on this paint, this material on top that would sort of make it smoother, and then it wouldn't wear off as easy. It would make it a little less sensitive though. Anyway, we also learned that using paint for cables was not the best idea. Well, lesson learned. So we actually started welding cables to it after a while. But you know what? It doesn't matter, because we did all that and we learned so much. We were over the moon. This is a picture of us just being super happy, going out to dinner to celebrate the fact that we had successfully made that project. So with all that said, you might be wondering, okay, Ramon, do you have it running? Is it running here? And the answer to that is yes-ish. See, I made a prototype to show at conferences. I call this the Mark I. And what happened with it is that, as you see here, I did paint it. I'm not as good a painter, but I painted it here. And the problem was that using the paint for cables, the Raspberry Pi doesn't stick that well, so it kind of got off. And so I tried to paint it, and then two of the connectors connected. This was 5 minutes before a conference. It was horrible. And so the paint wore off, and then I tried to wash it a little bit, and then it spread everywhere. It was a disaster. So I made the second version with crocodile clips. And this works remarkably well. Not just that, but I actually have it running here, and I would love to show it to you right now. So I hope the organizers don't mind if I go ahead and reshare my screen. because not only do I have it running here, I actually have Stepmania running here. Let's do it. Let's play a little DDR. So I hope you can all see Stepmania running. Gotta make sure that I'm not sharing my sound. Yes, I am not sharing my sound. So please, somebody please give me a shout out if you don't see Stepmania. But let's get into it because, oh, you know what? Let me move my camera. Sorry, welcome to my mess. Because here, I'm gonna just prop this on my MacBook. Ha ha! There it is. Let me point it a little bit lower so you can see the Raspberry Pi there. Not bad. And we've got our own little dance mat here. So we've got, sorry folks, this is a bit of a disaster. There we go. Just gonna move it a little bit forward. Yeah, cool. All right. So what you see here is the Raspberry Pis. Before here's our hours. You can even see that. Yeah, we can go up and down on Stepmania. And normally this cat button here would press start, but this crocodile cable here is not working. And yeah, so I'm going to be pressing enter on my keyboard instead. So suspend your disbelief for just a second, please. All right, let's dance. All right, let's choose a song. Hope the level is okay. Please give me a shout, folks, if it's too loud. It seems like it's loud. All right, let's go with the first song on easy mode because I'm not that good. It's much harder with your hands than with your feet, believe it or not. All right. Oh, you can't see me, but I'm dancing. Normally I'd ask for a volunteer, but for obvious reasons, it's just me. Well, I think you all get the idea, huh? Let's reshare my slides here. Thank you all for your patience. Just gonna take the camera back and put it up here. Yeah, this is a bit of a mess. Bear with me, folks. All right. Yeah, so as you can see, it works. It's a lot of fun. And so here's the thing. This prototype here, you know how this is just paint, right? So this can go on any surface. So computer, if you don't mind flipping, please. It's a pizza box. Yeah, so as you can see, it works. It's a lot of fun. And I've taken this around the world to show it to folks. I even set it up at a conference once where people could just come into the Mozilla booth and just jam out on it. It was a lot of fun. I am so grateful for this. So I realize I've been at this for a while. So I'm going to give you some takeaways, folks. If you haven't done a lot of hardware hacking before, it looks daunting. And in a way it is, because whereas your code can break and it's, you just have to run it again. With hardware, it can be a little scary. I mean, you saw with my Mark I, when I messed it up, I had to start over. And it can be it can be scary, but it happens. It happens to everybody. This is prototyping. This is messing around. So you will have to, when I travel with this, I do have to carry a spare SD card, for the operating system, and a spare Raspberry Pi and a couple. I know I didn't do that good a job here because my crocodile cable died, but I swear it was just before the conference started, before my talk started. In any case, you had to be prepared. It was really interesting to learn the look behind the mirror of behind the curtain of how this stuff works. It really reminded me of the joy of playing around with stuff, of messing around with my already existing stack of JavaScript, of scripting, of Node, the things I understood of Linux, and taking that a step further to understand better how things like buffers and file interfaces and how this sort of thing works. The community is so vibrant and so positive. There's so many good resources and packages out there that you can totally use to improve your knowledge and make your dreams come true. So my big takeaway for you folks is, if you've got your idea and you want to try it, just go for it. What's there to lose? Folks, you've been a delight. I cannot thank you enough for coming here today. If you want to talk to me about hardware stuff, if you got some neat ideas, if you're into DDR or music games as well. Oh, actually, I played this with Crypt of the Necro Dancer as well. I don't know if you've played that. It's so much fun. This totally works with it as well. It's a joy. Thanks, folks. Have a good one. Enjoy the conference.
Okay, so good afternoon and good evening or good morning, depending on where you are tuning in from. And welcome to this presentation on why you should consider WebAssembly in your next front-end project. So my name is Håkan Silfvernagel, and I work as manager for AI and big data at a Norwegian consultancy company called Miles. So the agenda here for today is the following. So first we're going to go through what is WebAssembly, and then we go through Hello WASP program, and then we're going to talk about Rust. I will give you an introduction to Rust, and then we'll talk about how can we write the program in Rust and then compile it down to WebAssembly. And we'll see how can we make a game of life, and then we'll talk a little bit about performance, about some real-world usage, and what are the future plans for WebAssembly or WASP. And then we're also going to have a quick look at other frameworks that are using WASP. And then we have one item here on our table of contents called New Old. And then we finish with some conclusions and some references. But before we start, I'm just going to give you some background information here about me. So my name is Håkan Silfvernagel. I work as a manager of AI and big data at Miles, and I'm quite involved here at the local user community here in Oslo. So I'm part of the Norwegian.net user group, and I'm part of the Oslo AI user group, and I'm also running the Azure user group Sweden. And in addition to that, I'm also running an online AI school called AI42 together with Eve Party, who's also an AI MVP. So I'm a Microsoft AI MVP, and I'm also a Microsoft certified trainer. And if you want to reach me, you can find my social media links here on this slide. But now back to WebAssembly. So first we will go through what is WebAssembly. WebAssembly started out in 2015. So there was a group formed by all the major browser vendors, and in 2017, WebAssembly was released. And then in 2018, we had the W3C public draft that was published. So this is important to take into account here, that WebAssembly is a W3C standard. So that means that it will work both on your laptop browsers, but also on your mobile browsers. WebAssembly is supported. So if we will compare JavaScript with WebAssembly, we can see that JavaScript is a high-level language. It's very flexible and expressive, and it's dynamically typed. And you don't need to do any compilation. And as we all know, it has a huge ecosystem that you can make use of. Whereas WebAssembly is a much more low-level assembly-like language. It has a compact binary format with near-native performance. And the way that you write WebAssembly is you use a high-level language like C or C++ or Rust and Go, and then you can compile that down to WebAssembly. And this is taken from a blog post from Lynn Clark, and what she tries to illustrate here is that usually you have compilers. They will take a high-level language, and then it will translate it to some sort of intermediate representation. And then another part of the compiler will compile it down to the target architecture. So in this case, the target architecture can either be an x86 architecture or an ARM architecture. But now with WebAssembly, the thing is that now we have code that will be executed over the web. So we don't know beforehand on which target architecture this code will run on. So you can say that WebAssembly is like a machine language for a conceptual machine. And you sometimes refer to WebAssembly instructions as virtual instructions. So the browser will download the WebAssembly, and then it can compile it down to the target architecture. So WebAssembly is a new browser standard, and one of the reasons why they could come out with it pretty fast was that it's based on some previous work. So if you want to know more about it, I encourage you to read on the asm.js project. And WebAssembly is also an intermediate language. So in the same way as Java can compile down to bytecode and C# will compile down to MSIL code, it works the similar way here. And with WebAssembly, we only have 4 types. It's 4 strongly types. So it's the 32-bit integer, the 64-bit integer, the 32-bit float, and the 64-bit float. And now we will have a look at how can we write our own Hello WASP program. And the thing is here, as I mentioned here before, we only have 32-bit and 64-bit integers and floats. So we don't have, for example, string. So that makes it a little bit tedious to write a Hello WASP program. So what you usually do when you want to write your first WebAssembly program is you do a mathematical operation like addition or subtraction. So here we have a WebAssembly example. We have add and WAT, which is the WebAssembly text format. So we can define our module, and we call our module consists with a function that we call add2, which takes 2 input parameters that is of type 32-bit integer. And then it will output the result, which is also a 32-bit integer. And WebAssembly is a stack-based language. You can pop and push on the stack. And then you have access to some 70 different types of operations. So one of the operations is the integer 32 add operation. And then finally, we need to do an export so that a calling application can use our WebAssembly. So we export this as an add2, and it refers to the function which is also called add2. But if we would have a look at what it actually looks like, so as I said here, WebAssembly is a binary format, but there is also a tool called what2wasp that you can use in order to have a textual representation. So you can see that it looks very much like assembly-like language, as you can see here in this picture. So if you want to use our WebAssembly, then what we do is we can write an HTML page where we are fetching our WebAssembly or binary file, and then we read it into an array buffer. And then after that, we can, since WebAssembly is a standard, we can just call WebAssembly.instantiate with this array buffer that we just read in. And then after that, we can assign add2 to this result.instant, and then export, and then the name of our function, which was add2. And then we can perform the actual operation as here by calling add2 with our input numbers here. And then we can alert it out on the console. So if we run this, we will have out that on the result here from our WebAssembly edition. And then another tool which can be interesting to know about is the WASP Code Explorer or the WebAssembly Code Explorer. So what you can do here is you can take a binary file. So here I've taken this binary WebAssembly that we've made, and then we can load it up into this tool. And then we will have a textual representation of our binary file. And we can see that it looks just like the way that we have defined it from initially here. So now when we know a little bit here about WebAssembly, so as I said here in the beginning, we don't really want to write WebAssembly from scratch, but what we rather would like to do is we would like to use a high-level language, and then we would like to compile down our high-level language down to WebAssembly. So in this example, we will use Rust. So in order for us to understand a little bit more about Rust, we will have a quick introduction to Rust. So Rust comes from Scylla. It's a system programming language. It has a syntax very similar to C or C++, and it's strongly typed. And it compiles down to native code, so you don't need to have any virtual machine. And one of the design goals when they made Rust was that it should be memory safe. And that means that you will not have any dangling memory pointers or anything, and you don't need to have any garbage collector. So when we talk about Rust, we should also talk about our Rust toolchain. So Rust toolchain consists of the Rust app, which is an installer for Rust, and Cargo, which is the Rust package manager. And so what happens here is that with Cargo, you can download a Rust project dependencies, and it can compile to your project, and it can make packages, and then you can upload these packages to crates.io, which is the Rust community package registry. And an example here of a Rust Hello World program, we can see here is we define a function, a main function. And in this main function, we print out the line Hello World, and then we can compile it by using Rust C and refer to our main Rust file. And then on the Windows system, it will result in an exe file that we then can execute. And it will, when we execute that, it will print out Hello World on our command prompt. And as I said, we also have this package manager called Cargo. So we can also use Cargo to generate a new project for us. So if we run Cargo new Hello World, it will create this folder structure that you can see here on the right-hand side, where we have one main Rust file, and then we have a cargo.toml file. So the main Rust file, there will be a function called main, and in that function, we can define what we wanted to do. So here we will just print out Hello World. And we have a cargo toml file, which is a package definition here. So we define the name for our package, and we define also if we have any type of external dependencies. And then we can use cargo run, so that will be compiling our Hello World application. And after that, it will run the resulting hello world.exe file. And as we can see, it prints out Hello World on the console. So with Rust, we also have a type system. So we have primitive types, and we also have primitive constructs. So among the primitive types, we have, for example, Boolean, we have chars and strings and integer and floats. And among the primitive constructs, we have tuples or arrays, references, and pointers. So now when we know a little bit more about Rust, what we can do here is we can write the Rust program, and then we can compile a Rust program down to WebAssembly, and then we can package our WebAssembly into an NPM package, and we can upload it to NPM. And then after that, we can create a new web application where we can use our NPM package. So that's what we're going to do right now here. So in order for us to be able to compile our Rust programs down to WebAssembly, we need to install this Rust toolchain. So that was what we were looking at previously, which is the Rust app, the Cargo, and the Rust compiler. And then we need to add the wasp32 unknown target in order for us to be able to compile down to WebAssembly. And then finally, we'll need to install a package called wasp-bindgen. So wasp-bindgen package will generate bindings to and from JavaScript for our WebAssembly. So I will also refer to this bindgen as some glue code. I will mention it further on here in the presentation. So here's an example here. So here is the cargo toml file. which is our package definition. So we have the name of our package, and we have what type of crate it is. So here we create it as a c.lib, and then we also need to specify if we have some dependencies. So right now we have a dependency on the wasp bindgen. So wasp bindgen will generate a glue code so that we can call our WebAssembly from JavaScript. And then we also get our library Rust. So here, the first thing that we need to define here is that we want to make use of this an external crate, which is the wasp bindgen. And then after that, we can specify here that we want to use an external function, which is the standard alert function in JavaScript. And then finally, we define our own function here, which is called greet. So the greet takes a string as an input parameter, and then we use the regular alert JavaScript function, and we format our output here. So it prints out hello name. And then we can use wasp pack init in order to generate a package out of this. So if we change to the package directory, we can have a look at what it looks like. So as you see here on the right-hand side, we have four files here in our package directory, and we will have a quick look at what they contain. But if you want to publish this to npm, you can just publish it as any other package by using npm publish package. And then as we can see here on npm, we get the hello wasp silver package published up to npm. So if I have a look at these 4 different files, so the first file is a TypeScript file, and in the TypeScript file, it defines the different types of functions that an external application can call. And then we also have something called hello wasp silver.js, and this is this glue code. So this is what we're using this wasp bindgen package for. So this is generated for us. So, so as we can see here, for example, in the greet function, it tries to pass a string down to wasp. So it tries to return wasp.greet with our input parameters. And then it also frees up the memory here in WebAssembly. And we also have a package.json file, which is just a regular package.json. And we can find a webpack file for us, where we can have an entry file and index.js. And we have a package.json file where we just have a dependency on this hello wasp silver package that we just generated. And if we have a look here at our index.html file, the only thing that we do is we refer to this index.js file. And in the index.js file, we import the hello wasp silver package, and then we can load it asynchronously. And then we just can call the greet function with something that we want to be printed out here on the console. Now we can see that it will print out that on the console here. So now we'll have a quick look here also at a little bit more advanced example here, which is an example of game of life. So I'm just going to take some water here. So with game of life, what game of life is like a simulation of different cells that needs to abide by some rules here of this game. So if you have a live cell with fewer than 2 live neighbors, it will die because of underpopulation. And if you have a live cell with 2 or 3 live neighbors, it will live on to the next generation in the simulation. And you can also have a live cell with, if you have any live cell with more than 3 live neighbors, it will die by overpopulation. And if you have a dead cell with exactly 3 live neighbors, it will become a live cell through reproduction. So if we have a look at how this is looking like, so if I start our simulation here, you can see this is getting simulated, and then we can pause our simulation by pushing the blue pause button like this. And then now we can go into our simulation board, and now we add some new cells here, and then we just continue our simulation. So let's have a look here how that was made. So again, here we have a TOML file, a package definition here. So our package is called Wasp Game of Life, and it's the same type of crate as previously, or cdilib. And we also have the dependency on this Wasp bindgen in order for us to generate this this glue code so that we can call it from a calling application. And then in our Rust file, we define a universe or a simulation here with some width and some height. And then we also have some getters and some setters for the width and height. And we have here a toggle cell function so that we can toggle a specific cell based on the row and the column. And then again, similar to what we had in the previous example, we have a TypeScript file, and in this TypeScript file, we can see the different types of functions that a calling application can run. So for example, new and render, and get the width and the height, and also the toggle cell. And we also have this JavaScript file, which is this glue file, which is generated by our bindgen package. So for example, we get accessors for the width and for the height, and for our toggle cell function, you can see here that it tries to call wasp.universe toggle cell, for example. And then we can create an index.html file where we refer to bootstrap JavaScript file. And in our bootstrap JavaScript file, we will again load this thing asynchronously. And this is just to show you what it looks like. So here we can, for example, call this universe.toggleCell function with a specific row and column column. So now when we looked at the game of life, we will also look a little bit more here into performance. So here we have some example here where we have some different browsers. So we have Chrome, Firefox, and Safari. And then some people have made some experiments both with JavaScript and WebAssembly in these 3 different browsers. And what is interesting here for us is that, first of all, we can see that with JavaScript, we get much more spread out results. So you can see that the spread is much higher. The red dots have a much higher variance than the blue dots, for example. So that means that if you're going to be using WebAssembly, you can be much more certain of how much time your operations will take. It is much more predictable than what it is with JavaScript. And we can also see that WebAssembly is faster than JavaScript. And one of the things that we need to take into account here is that we've had JavaScript has been around for quite a long time. So that means that we have been able to do a lot of optimizations, whereas with WebAssembly we haven't had that much time to do these optimizations. So probably with time, WebAssembly will be even faster than what it is today. So now I would like to tell you a little bit here about some real-world examples. And before I do that, I should also mention here that some practical use cases here for WebAssembly is if you want to do something which takes, which you need to be able to perform something really fast, like for example, a game or a mathematical operations, or maybe you have some sort of graphical calculations that you need to do. Or another way that is also a good use case for WebAssembly is if you already have some code in, for example, C or C++, and then you want to be able to expose it to more people by putting it out on the internet. Then WebAssembly is a really great candidate for that, because then you can expose it through a JavaScript application. But in this example here, this is a digital signal processing library, which was written in C. And then what they did is they used WebAssembly in order to be able to put this out as a web application. So if I have a look at what this looks like, it looks like this. So here we can see this is a video file that is rendered, and then we can apply different types of filters here in real time and see what it looks like. And it's the same both for live video or for static photos. And the second example here is AutoCAD. So AutoCAD has been around for a long time, and what they do is they have a specific product, AutoCAD, in order to generate drawings. So they started out here in 2010. They made a Flash app so that they could show their drawings out on the web by using Flash. And then if we fast forward to around 2014, 2015, they made an HTML5 JavaScript application, also so that people could view the drawings on the web. And then in 2016, they made their first ever AutoCAD C++, which was compiled with Emscripten, which is also a different type of compiler. And then they also made something called a real DWG-based viewer in 2017. And then finally in 2018, they made the AutoCAD web app was launched. And one interesting thing with this AutoCAD web app is that they have used the WebAssemblies. The way that they have made this architecture is quite interesting. So they're still keeping their AutoCAD core functionality, which consists of C++ code. And then they make a layer with the WebAssembly so that the JavaScript can call down to the AutoCAD core C++ code. And then you can use any type of UI component library. So you can use React or Angular or Vue or anything else. So this also is a nice example of a separation of concern. So this means that you have your web developers can focus on programming in their favorite framework, and the people that has been working on the AutoCAD core can continue working on that using the C++. And then you can reap the benefits by using WebAssembly as sort of a bridge between the JavaScript world and this C++ core code. So now I'm going to say a couple of words here about some future plans here for WebAssembly. So maybe, as you have seen here, we've always had to use this WASP bindgen in order to be able to call our WebAssembly function. But what they would like to do here, is they would like to be able to call directly down to the web, to the DOM, or to a web API. And another thing that they would like to do is they would like to be able to directly import the WebAssembly in JavaScript. So as you can also see, we've always loaded our WebAssembly modules asynchronously, but they would just like to be able to just do an import of the WebAssembly component. And in addition, they would like to be able to support more languages than what is supported today. And another way that we can use WebAssembly is called serverless WebAssembly. So WebAssembly is not only for the browser. So we have providers like Cloudflare and Fastly. They support serverless WebAssembly. And this means that we will have faster launch time. You don't need to rewrite your JavaScript, your business logic to JavaScript. And you can also have much more lightweight applications. So an example of this is, we can see here. So one way that you can do is you can have all of your logic and your calculations server side. So that means that you have everything of that in the backend. So it can be some C++ library, and then you just have front end in JavaScript. Or you can run everything on the client side. So you can do your calculations in JavaScript and have everything running on the client side. Or you can run client-side WebAssembly. So then you have compiled your C or C++, and algorithms down to WebAssembly, and then you can make use of it from JavaScript. Or you can have this serverless WebAssembly. So then you have your main front end, which calls down to a serverless function. And in the serverless function, you have also compiled your C or C++ code down to WebAssembly, and you will be able to run it serverless. So one interesting question that we can ask us is how long time will this take? Because you always have some sort of an initialization time. So with Google Cloud or with Amazon Web Services or Azure, if you want to run a node serverless function, you usually have some sort of initialization time of 200 milliseconds. But then we have Fastly. They have made a runtime that they call Fastly Terrarium, or they call it the Lucet. And with the Lucet runtime, you get this initialization time down to only 35 microseconds. Or with Cloudflare workers, you use the V8 engine, and then you get the initialization time down to 5 milliseconds. So this can be worth exploring if you want to explore this further. And then we also have something called the WebAssembly system interface. So this is for if you want to be able to run your WebAssembly outside of the browser. So as we spoke about initially, you can see WebAssembly as a language for a conceptual machine. And then you also need some sort of an interface here for a conceptual operating system that can be able to run on all types of operating systems. So again, this is from Lynn Clark, and usually what you have here is if you have some sort of a code that wants to be able to use some system calls, like for example access the hard drive or something, you need to go through some sort of intermediary that will grant you the right access. So in this case here, we have the WebAssembly. It will call some sort of an intermediary that will give the WebAssembly the right read and write access to the hard drive, for example. Yeah, so you can read more about the VOSI here on the WebAssembly system interface page. And I think I will skip over one of these examples here, actually. So we're also going to talk about some other frameworks that is also using WebAssembly. So one of these frameworks is called Pyodide. So Pyodide will bring the Python runtime to the browser through WebAssembly. And along with that, we will also get some standard libraries like NumPy and Pandas and Matplotlib. And the way that this works here is that you can write as you usually do in a Python or in a Jupyter notebook, but in this case you can run everything on the web in the browser. And you can have some visualization and some simulations directly in the browser through this Iodide project. And then we also have something called AssemblyScript, which is a language made for WebAssembly. So AssemblyScript will compile a strict subset of TypeScript down to WebAssembly using another compiler called Binarin. And the way that it works here, so here we have some rotating function. And then what is important here is that you are responsible yourself for allocating memory and also to free up or deallocate the memory once you are done using it. Then we also have a framework here from Microsoft called Blazor. So Blazor is basically a framework where you can build web applications using C#. And the way that this works is you have two types of flavors here. Either you can run Blazor on the server, and then you will transfer your client events will be sent back using a technology called SignalR, or you can run it on WebAssembly. And then you have a specific version of the .NET framework which runs on WebAssembly. And the origin of this was at in the C conference in 2017. There was Microsoft developer called Steve Sanderson. So he showed how he could use Mono, which was an open source implementation of the .NET framework, and he could use Mono as a compile target for WebAssembly. And by doing that, he could run C# code in the browser. And at the same time, or around that same time, we also had the ASP.NET team that was working on this new framework called Blazor. And the way that Blazor works is that you have your C# files and you have your Razor files, and then you can compile this down to .NET assemblies, and then you can run it in your browser. So an example here of how you can do is you can define, for example, here you define the counter and the button so that you can increment the counter here, and then you can run it. You can run it in the browser. And if you do that, if you run this example in the browser and you load up the web developer tools, then we can see here that, for example, we have this JavaScript file, which is this glue file. We have the mono.wasm, and we also have some other files that usually you're not so used to be seeing, like, for example, the MS-corelib DLL or the Microsoft JS interrupt DLL and so on. But you can also use F# in WebAssembly. So there is a framework called Bolero so that you can develop your own SPA applications with the full power of F# and .NET. So Bolero is built on top of Blazor, and it will add some features which are designed specifically in order to work in F#. So now that we've seen a little bit about WebAssembly and what it can do, then we can also ask ourselves here, isn't this a question of some new old? Haven't we seen all of this before? So for those amongst us who have been around for some time, you might be remembering the ActiveX components and the Flash components and the Silverlight components. And all of these were not so, they were great at one time, but then they quickly faded out. But one important difference between these previous frameworks and WebAssembly is that all of these frameworks were proprietary frameworks, whereas WebAssembly is a web standard which is supported by all browsers. And I think that is what will make WebAssembly survive a lot longer than these previous attempts that we've seen before. Now I'm coming to the end here of my presentation. So the question here is, what kind of conclusion can we make? So, so when I started out this, there was a lot of talks about that JavaScript is dead and WebAssembly sort of the new king. So the question is, should we do WebAssembly all the things? Well, if you ask me, I wouldn't really say so, because I would say that there's still a place both for JavaScript and WebAssembly at the same time. So WebAssembly is just a new tool in your toolbox, and it has some very specific use cases, like for example, if you have some already existing C or C++ code that you want to be able to expose on the internet, then you can use WebAssembly, so you can compile down your C and C++ code to WebAssembly, and then you can write web application and expose these applications out on the internet. Or if you have some code that you need to run fast, so then you can write your logic in C or C++, and then you can compile these calculations into WebAssembly, and then you can run it through JavaScript. So I also have some references if you want to learn more about this. So first, there are some articles here about WebAssembly that I encourage you to read. And if you're more interested into this new framework from Microsoft called Blazor, you can see the Blazor framework on GitHub, or you can watch this initial presentation here on YouTube from the NDC conference. So with that said, I would like to thank all of you for watching this presentation. And if you want to reach me, you can always reach me on my Twitter handle, which you can see here, which is Zagrevlis, or you can send me an email on this email address that you can see here on this slide. And I also encourage you, if you have any questions, you should just sign up for the JavaScript and Friends Slack channel, and then you can ask your questions in the Track5 questions. And now I can see we have some minutes left here, so then I would like to take the opportunity just to talk a little bit more about this online AI school that I was mentioning here in the beginning of my presentation. So this online AI school is called AI42. So I'm running it together with Eve Pardy, who is an AI MVP from Denmark. And the way that we've done this is we would like to give everyone here a chance to get into this interesting field of machine learning and data science. So we have been streaming every second Wednesday at 5 o'clock Central European Time. And we invited in both recognized speakers and industry experts that will teach you about a specific subject. So we started out with the basics about mathematics and statistics and probability theory. And after that, we've moved into languages such as Python and R. And then now we looked more into tools like Databricks and Power BI. And we also look into how can you actually set up a machine learning pipeline so that you can set your own machine learning algorithms into production. And we also looked into some deep learning and some other things. So the idea here with this online AI school, it will give you the necessary knowledge so that you can go all the way from complete beginner to the stage where you'll be able to build your own model and set it out into production. So if you want to know more about this, you can either reach us on our Instagram page, or you can reach us on Twitter or on Facebook. And if you want to see our previous session, you can scan our QR code to reach our YouTube channel. And if you want to sign up for our new events or our new sessions, you can sign this QR code, which will take you to our meetup page. So with that said, I would once again thank all of you for attending this session. And if you want to reach me, you can reach me on this Twitter handle here. And I'm going to make a quick check here and see if there has been any type of questions on the YouTube channel. And it doesn't look like that. But if you have any questions, again, you can also sign up for the Slack channel, and you can ask your questions there. So with that said, I would just like to thank all of you for attending this session, and I wish you a continued nice conference here. Thank you. Thank you so much.
you.